Okay, well that more or less worked. I think I made a landing here finally. Okay.
Yeah, the only thing is it kicked me off
Uh,
as co-host. So
oh, okay, and we have to start the recording on Zoom. So, okay, I'll make you co-host. Okay, you're recording now, and I'll record to the cloud.
Hey Rick, everybody.
Hi, Brett. How you doing? I
I'm good.
just right on. I'm just getting started here. So it's the Tuesday night on this part of the planet so far. Keshe Plasma Reactor Group. I'm Rick Crammond, your host, and it's January 31st, 2017, last day of January of this year. You're probably in February 1st, other people in other parts of the planet, and I will be as we get into the evening here. So we have a guest, $4 fish on a $5 Friday. Okay, well, that's interesting. And we'll have to find out what that's all about, I guess. And okay, let's get into it here. And wonder if anybody has anything special to report for today.
$4 fish on a $5 Friday. It's just me.
Peter. Correcto. Good. Okay. Well, it's always good to be incognito. You never know who might be trying to follow you. But if you're a $4 fish on a $5 Friday, you're probably leaving a trail. Anyway, let us carry on. Lee, we generally start with you, but I don't see your video up yet, so I'm a little suspicious. Were you sick this week or something? Oh, I don't not
because
here.
I don't have a heck of a lot this week.
Okay. That's why I thought that you might have been down for the week or something, but no, you always have something. No, let me just wait. Let me get you pinned here. There we go, and spotlighted.
So has anyone heard of a Clive connector?
A Clive connector.
It's I guess you'd call it a modified Western Union.
Modified Western Union. Okay. Modified
Basically,
in what sense? Yeah.
in a Western Union splice, you'd have you'd go to your center point, and then this wire would wrap around that wire, and from the center point, this wire would wrap around that wire. On this splice, you've actually got it the other way around. You've actually got the two coils pre-made, and they just slide inside each other. Some guy on Frazzle's group called Clive came up with that. What I've been using this for quite a while, and he doesn't have the ends come all the way through. What I bring my ends all the way through, and then I give them the twist on the end. These aren't twisted yet, but I came up with this. I got the inside coil turned 180 degrees so that the connection ends down here and the other connection ends up there, and that way I can get my connector straight across. And if you wanted to, you could separate the two because of this connection, and you could pull it apart and separate it. But the other way is you can pull it down and you can gans one coil, like I usually do my connections, and then I nanocoat it a second time, go through the process of nanocoating again.
Mm-hmm.
But then you got to gans it, so you can this way you can pull the one down, gans it with one gans,
and flip it around.
Gans another row with a second gans.
Wow. Okay, yeah.
Normally they're all tied together, and you'd gans it all in one kind of gans. So that was
right. Well, this is sort of it's like the Armin connection, but it's sort of a double Armin connection, you might say, or it's almost a a Western disunion in a way, because you can undo it. That's the difference. Unless you, of course, if you turn over the ends, I guess it would be difficult then. But
Yeah, you could always cut the ends off if you wanted to undo it if you were desperate.
yeah, and so they are never tight, right? They're always sliding over the wire, so you could be gentle with it and probably not disturb the nano layers and whatnot.
Yeah, well, I would make it solid and turn the ends over and then nano coat it.
Nano coat
so it's
again,
all
like
solid one.
yeah.
But then because these coils sort of separate up and down, you could gans the inside coil different than the outside coil without doing minimal damage to the nano coating.
Well, yeah, and
that's what I'm trying. That was my goal, is come up with something where I did minimal coating to or damage to the nano coating.
Are you able to? Sorry, go ahead.
Has anyone ever tried this where they turn the inner coil 180 degrees? And
well,
we've always done our magrav coils where the connectors were always both in the same spot.
Well,
South Pole?
Say again?
Isn't that like a North and South Pole? So your gravitational would be almost like north and your magnetical would be south.
Well, I think it would be if you had a disturbance in your actual toroid field, there'd be one little weak spot. This way, it distributes the weak spot instead of stuffing it all in one side.
Or you could look at it like we did a few weeks ago with the what's the name of the coil that's it's like a circle with a gap in it, and then there's another circle with a gap in it going backwards, like just the way Lee has it here, and then another one inside or another one outside with the same configuration. What was the name of that? Somebody remind me. It was a resonating oscillator coil. Just coming to me slowly. Something oscillator. Well, and there's a prize for the first one who puts it in the chat. Maybe
is that the guy in Europe who had the sort of the antennas going back and forth?
Yeah, that he had sort of an example of it, but there was a name for the original mechanism. It just escapes me right now. But the idea is that it acts like an oscillator, or sort of like if you can imagine. At one end of your coil where the gap is, say one coil on what we see on the right side of our screen here, you have the gap, and then you have the other gap in the smaller coil about in the middle of our screen. Well, the two ends where they come together with this oscillator, it's never even where the two ends come together, and because of that, there's always an imbalance, and because there's an imbalance, it starts to oscillate from one side to the other through the coil, and then it becomes an oscillator, and you can have a series of them, and they either concentrate down or disperse out, and they resonate at different frequencies, and if you have enough of them, then there'll be one that's self-resonating and makes the other ones go, and so on. So it becomes more of a self-resonating circuit, and they actually make it in nanoscale now too, for antennas and whatnot. Anyway, carry on there. Yeah, I was going to say, Lee, is it possible? You mentioned rotating, and I was thinking, can you rotate that middle coil that 180 degrees? To make them different. Can it do that with those kind of connections, or is it not free to do that?
You mean something like that?
Wow! Now that's cool. So that was quite easy, wasn't it? And that actually looks pretty neat there too. Huh, interesting. Now the question comes up. Let me just follow through on this idea, which is, now you have a way, in a way, to vary it from this configuration to the other configuration. What if you had a gans ball in the middle and so on, and you're able to change your orientation at will, And also the up and down, when even when they were horizontal, you were able to change the up and down of from one coil to the other. So you're changing the fields basically. You have a field control mechanism through this slip connection, it seems. Congratulations, Leah. It's a major step for the spaceship configuration. No,
There's
that's. Go ahead. No.
another interesting thing about this design is the wires coming off here come off in a sequence in a row. So you could have a little plate of plastic there with some holes in with the wires coming through, and that would hold your coil ends right where you want them without any wires touching each other. So in the other normal way of putting the two together, you got cross wires, and I'm always in there with a hot glue trying to make sure that there's a gap between the wires to so that they don't short circuit or whatever. This coil, this configuration, the wires come sort of, you can bend them straight up and they're all separated. They're not crossing each other. So, which I think is a good idea. So that means there's less hot glue and less playing around before you sort of set them in your case or whatever. So.
Very nice.
John, on a video you were doing there about the car magrav units there that you posted there about a week or two ago, you were talking about the gans on the coils, and it sounded like you were saying the inner ring would be one gans and the outer ring would be the second gans. And I'm thinking you were the way on that video you were talking about this whole inner coil and the whole outer coil would be two different ganses as opposed to the coil inside the coil being two different ganses. Is that correct?
Well, yeah, this was based on what Mr. Keshe was talking about, I think 3 or 4 weeks ago on the show here, where he simply used the word coils. He didn't delineate between a coil, a loop, and a layer. So I'm thinking, okay, well, first steps, let's make this simple. Let's just do the loops, okay? So you've got a heavy gans on your inside ball, you got a medium gans on your inside loop, and you've got a light gans on your outside loop. Both coils within each loop would be the same gans. If that proves out, then we can go to the next step and we can gans each individual coil, then make a loop out of it. So each loop would have two different ganses. You understand what I mean by coil, loop, and layer? The coil is the spring, right? There's 4 springs in each layer. The loop is the assembly of 2 springs together, making a circle. And then the layer is the assembly of the 2 circles together, making what you have in your hand. There's been a lot of debate about this, and most people think that Mr. Keshe was talking about nano-coating individual springs and then assembling them into your loops. So you would have essentially 4 different layers of ganses within your assembly. It makes sense to me. It certainly does. It would probably work awesomely, but as a first step, what I was suggesting when I did that video was to simply do, you make your assembly and then you coat the inside loop with one gans and your outside loop with the other gans, which is a fairly simple thing to do. I mean, you can set it up on a rack over top of a tub and take a squeegee or a squeeze bottle with your gans in it and just squirt the coils, right? The way you've got it, sure, you can dip them.
Yeah.
But most people aren't baking them like that. But we'll see.
That's yeah. So yeah, because the other way where you got you're gansing the coils within the coils, it's very hard to do that without damaging your nano coating.
Yeah, that's what I brought up in the show is if we nano coat everything and then try to assemble it, we're going to make a mess.
That's my thoughts. So anyway, that's why I haven't actually made a car magrav using this yet. That's in the works. So we'll see how it works. But I think it's going to help a lot in not damaging the nano coatings just by doing it this way.
Oh yeah, I certainly see it. It's gorgeous. I love the way the connections are simplified. Nothing's crossing, because on the systems that I make, I've got one that crosses another one, and it's always tough trying to get it oriented just right. And I usually push it out to the front so it runs across the front rather than along the top. And it's, you know, you got to really think about it. And assembly is a problem because you're working with really short, really stiff wire. No, I really like your plan. I'm going to do a couple of sketches and make sure it's clear in my head. And when I can come up with some more wire, I'm going to make a few of those and see how they work.
Great. Just another, my fiberglass balls, I've been putting a hub on the end of them with a bearing inside cast in place. So eventually I'm going to get them on my spinners here and have a second shaft on the top bearing so that the thing doesn't wobble. But
What?
Another project in the works.
Wow, that's a great idea. What size bearing are you using there? What's that from?
It's a 1/4 inch by 1 inch bronze plain bearing.
Like a bushing, like.
Exactly.
Mm-hmm. Okay.
Yeah. So I'm hoping that won't heat up when I spin it at 10,000 RPM.
yeah, that's debatable. I have a brass bushing in my rotating sphere, and that's set up in the lathe here. And there's a stainless tube goes inside of it. And I was using some graphite as a lubricant, and it didn't really heat up, but eventually the tube did pull out of its adhesive that it had. So,
Yeah, I think, Lee, you're going to want a really tight fit between your bearing and your shaft and a really light oil. So if you can get like a 1/1000th clearance, half a thou aside, and run something like sewing machine oil, you should be okay.
Yeah, I think
or maybe it's
a little bigger than that, but
perhaps it's a self-lubricating bearing as the bushings. Many of them are. If it's like an official bushing, most of them are self-lubricated. Or was it just a piece of brass or?
no, it was an actual bearing. I bought at Princess Auto.
Okay, yeah.
It's a bronze.
Right.
So,
yeah, they'll be self-lubricated.
I don't know. I don't think it's impregnated with graphite or anything like that.
No, it'll have some oily stuff inside of it, but yeah, a little bit of sewing machine oil or something similar would probably be good.
And the other thing with this hub, if I wanted to have this top shaft, the centering shaft, I can drill that through and have the small ball inside attached to it, so I can spin the inside ball at a different rate than the outside ball too. If I set it up with two motors, motor on top, motor on the bottom.
Yeah.
So.
Yeah, just make sure if you have two metals that are sliding together that they are dissimilar metals. Like if you're going to put two shafts in there, don't use like a stainless sleeve and a stainless shaft because they'll pick up and weld themselves together at that speed.
Mm-hmm.
Okay. Well, I'm planning on using steel shafts in the bronze bearings, so.
Yeah, the steel shaft and the bronze bearing, if you use like a steel tube with a known inside diameter and you want another shaft going through it, then that central shaft inside the steel would be another piece of brass.
Yep, okay.
So you wouldn't have steel on steel. It would always be dissimilar materials of significantly different hardnesses. And then they won't pick up. It'll last longer. It'll just be more reliable for you.
Yeah, that would be getting into a triple shaft design. This design here has the motor on the bottom spinning the outside ball, and then the motor on top would spin the inside ball.
Right.
That's my plan. But like you say, I could go with a hollow shaft on top and then have pulleys and or gears on top to get the two shafts spinning or something with two motors on top too.
Yeah.
But
okay.
Not planning on doing anything like that just yet. Anyway.
Oops, just preemptively letting people know that if you're going to have two systems that slide together, they have to be dissimilar or you're going to have problems. That's all.
But could they also be creating the conditions that you would need for the fields? For instance, I was seeing that if you was putting brass and steel, am doing a rotation, creating a motion within the fields, or am I too off field here? um, of the actual brass and the steel be the conditions to create the
Well,
fields.
there would be some interaction of fields, but we know from what Armin has been telling us and our own experiences that the matter state field extension out past what we perceive as the surface of the matter is very, very tiny. It doesn't go very far. So there would be some field interaction between the matter spinning within another thing of matter, but I don't think it would be significant enough to consider, at least with the course systems we're working with now.
Okay, I was just kind of thinking of creating the ships that are going to take our souls out of here and or at least bring our souls above the earth for a while and trying to find those conditions we can create without needing anything else.
Yeah, well, so far, what we're seeing coming out of Arizona is there's no moving parts in them. So
Well,
I
see,
don't know.
that's what
Let's
I'm
see.
saying though. Maybe just those two things close to each other only need to be propelled once, and then the fields, because they might be so minute, might actually continue going.
No,
Um,
no.
Excuse me,
Too weird.
John. We're getting a big echo through your system there when you're not speaking. When you're speaking, it's fine, but when you're not speaking, it's echoing back through. I'm wondering if you can fix that in some manner. All right, sorry. Carry on there, Libby.
Well, it was just a strange, as I'm transcribing these um, wonderful workshops, I'm starting to understand that the fields a minute ratio, but the minuteness is so powerful that it creates the propulsion that's needed, the
Well, I
interaction.
don't know. I don't know about minute. The last discussion that John Bliven had from Arizona, his fields are 200-foot radius.
Oh, but I meant from the beginning. The first one out is maybe not as big as we are anticipating, but it then goes outward and continues going outward because it's just playing with all the different fields. I may be misunderstanding. I'm just as I go into these transcriptions, it seems like I'm getting an aha moment after another aha moment of understanding how the science and the spirit are meeting, the spiritual world and the scientific world are meeting together. In
Yeah, just be careful when you're mixing your nanomaterials and your matter state. They react dramatically different.
No, I guess I'm doing them all within my own body. So with thoughts and intention, and then trying to, because when Lee mentioned it was stainless and bronze or brass, I suddenly saw, wow, there's great potential there. But maybe I'm seeing it in a level that's, yeah. Anyway, sorry. I just wanted to add that in, that it seemed like there would be great potential in that mixture.
Thank you, Libby.
I could add maybe just a little bit briefly there. Someone else wanted to speak, but I want to get back. We were talking about the brass and or bronze and stainless. This is a stainless shaft here, and if you can see inside there, there's a brass tube that this stainless shaft goes into, and there you can see it there now, and it has a doohickey inside that's a standard Dremel tool attachment. And I did have, well, it's out in the kitchen right now. I did have a ping pong ball attached to this until last night. I spun it at high speed and the ping pong ball came flying off eventually after a series of tests. But the idea is that, yeah, you have two dissimilar metals here, and in a way, whenever there are two dissimilar metals, there's always some sort of interaction going on. And especially at high speeds, there could be some sort of interaction happening. Um, I know that with high speeds, with my other system with the rubber belt picked up energy and actually transmitted it to the metal shaft. and ended up energizing enough to discharge up to a 2 centimeter spark off the end of the shaft from the energy being picked up from that system. So in this
Wow.
system, I was working on this differently, and like you can see maybe on the top here, no, it's really hard to see unless maybe I turn the camera down. There's a bubble here right now. There it is.
And we do love our bubbles.
We love our bubbles. And if you think about this system, which I was been working on for a few weeks here actually, and been talking about so on the different aspects of a sonoluminescent bubble, which would be a bubble much tinier than that. In fact, I was trying to figure out how tiny it would be, and let me see if I can. I think it was about. This would be on my micron on my thing here. It would be smaller than that size we're talking about up here. It would actually, no, that's way too big. It's more like, I think it was about there. I think it was 3/10 of a millimeter. That's actually exaggerated, because if you see, it's basically about the width of a human hair or something like that. It's pretty tiny. That's the kind of size bubbles that they play with in sonoluminescent. They have a bubble that size in the very center of a globe like this, and it's because of its actions going on in that tiny little bubble, it starts glowing so much that you could see it even in a room with lights happening. You don't have to actually dim the lights to be able to see. It's very intense light, but at a very fine pinpoint sort of place. So but I'm thinking that if with that is a plasma in that center core, a plasma that temperatures go up into the millions of degrees, they say, in sonoluminescent situation. And not only that, but it's a plasma where it's open to new processes going on. You could introduce bubbles of different types, different gases. You could have different substances inside the globe. This happens to have the standard 3 gans combination here in a diluted way with a small amount of gans in there, not enough that you could see it right now anywhere, but it's in there. And you know what will happen at high speeds, even maybe with a simple rod, or in this case I'm going to try it with this just with the little what is it, cylinder inside there. I'll spin that at high speeds and see what that does to the flow inside. In fact,
Are you going to do it now?
well, let me get my stuff now that I've talked myself into it, because I do have a new snazzy little setup here that I wanted to show. So let me show that while I'm showing off here. Alrighty, this is the new snazzy little setup. And it's a bunch of parts that I already had, basically, except for this thing here, which is a nice little chuck for chucking things you'd like to chuck. Let me see, what have I got that's chuckable here? There we go, a little shaft. Can you come out now? Don't be shy. There it is. So, for example, to have a little shaft, say I have a shaft with maybe a ball attached to it, or some other device that we want to spin at high speeds. I can open this up and open up big enough here. It's actually pretty big for this chuck. There we go. And I can use the key and actually tighten it down and so on. Actually, let me do that before something happens. And there we go. We have a nice little setup that's ready for testing of, for example, oops. I just went to grab my shaft and it fell off. It fell off inside my jar, so I'm going to have to retrieve that before I start playing with it.
Well, that was a message from the universe. Maybe not now.
Yeah, well, yeah, probably would have gone wrong here if I would have tried it as is. But I have a couple of other things I can do, and actually I can do it as a desktop thing here, because I can set this up on top. Whoops, I can set it up on top of the sphere is what I was trying to show here, and actually rotate. Well, actually I could stick this in here. Come to think of it, it did fit. And now, let me just get it a lid here. You see the whole setup is sitting here with the shaft goes inside the sphere, which is kind of cool. I don't know if that would be enough to actually do anything, but I have to remove that. So what I've
Cool setup.
what I've got is somewhere here. I can find what I did with it. 1 second. Controller. Ah, there we go. So here's the really cool part about it. Whoops. Sorry, everybody. I just knocked you over there. Okay, we're back again. It was traumatic. Okay, so the cool thing is that I've got this controller to control the speed of this unit, and it's totally self-contained. It doesn't need to be plugged in except for recharging. So let me see which way does it go here. I think I turn that on first and then turn this on. Makes a nice little sound. And it's pretty fast, very fast. I haven't actually done an RPM check on it yet, but you can tell it's fast. So I'll put it inside the globe here. This could be a disastrous thing, probably, but it's got to be fun. So I'll take a chance. Let me let the camera down a bit, line it up. Yeah, I think I should back it up a bit here.
I wish that
Right.
this is going to be beautiful. Beautiful.
Right in front of my computer. That's a good place to do this. Yeah, right. I don't even have the thing on the bottom that I. Okay.
Okay,
That's
well
all
then
right.
don't.
It's all
The
good.
thoughts.
It's
No,
all
but the
good.
thoughts.
It's
The
so-
thoughts you put out are so powerful. Let's just reprogram this for ourselves. It's going to
Yes,
work
right.
so well. Think about what your intention is to have a beautiful experiment that goes well, and everything you need to do that is within you and within all of us going, Yahoo, brother!
Thank you, Louis, for that blessing. That's a correct way to do things. So I hadn't planned on the whole thing rotating. interesting, actually. In spite of all the noise and vibration, that's exactly what I wanted to find out about. So,
Yay!
for an initial experiment, it's quite successful. Yeah, that was fun. So yeah, the little thing really puts out, the shaft has a bit of a bend to it here, I think. So, and plus a shaft will tend to vibrate at its resonant. Let me get my head, otherwise I'm a talking mouth. The shaft will tend to vibrate at its resonant frequency depending on the diameter of the shaft, whether it's a tube or a solid shaft, and primarily the length. So for example, if we were to I don't know if I had that.
So what was pulling the thing that was inside of there? What was pulling that up? Just the vibrations? Like
What was, pardon
the
me?
Dremel inside the globe
Yeah.
was moving as well.
Yeah, well, I think that was mostly from the vibrations. What I was trying to do was, since this is actually sort of going in a little loop when it's at high speed, it starts to vibrate sort of in a circle. I thought it would start stirring this and create a vortex and maybe start stirring that other shaft up that's inside there
That's what
and
I thought it
have
was
it
doing.
spin.
It seemed to look like that. Maybe you'll have to look at that again.
Yeah, because I will be investigating this more for sure, because what's happening is very interesting to me. When you think about sonoluminescence, which is basically, a bubble that is expanding and contracting very rapidly. And every time it contracts and expands, it gives off a flash of light. So it's flash, 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 flash as it's expanding and contracting. And sonoluminescence is just using interacting ultrasonic sound waves, and they form a standing wave that becomes a place of voidness in the water, essentially. And that slams back together and so on according to this standing wave that's formed in the vessel. Well, my idea is that maybe we don't have to use sound waves in that sense, or a special ultrasonic transducer that they use, and try to focus all this sound energy on there. Maybe by just rotating this shaft at the same frequency, say it might be in the neighborhood of 20,000 hertz, that's 20 kilohertz, which is above our normal range of hearing, but it's still in the sort of audio or near ultrasonic range. And that will be at that resonant frequency of that bubble. And if this is vibrating and rotating at the same time, maybe it will create its own bubble that expands and contracts with the right configuration on the tip here. Right now it's a tube. Maybe the tube will be a way to do it. Maybe a needle tip would be good. Maybe a needle tip with a little shot of argon gas coming through. It turns out that 5% argon is a perfect mixture to create that sonoluminescent. It makes the bubble work much easier. And that's relatively easy to do with an arrangement something like this. But I think just the right shape of tip might be enough in itself to create that bubble action. So in effect, you could create a light that's lit by a rotating shaft, and that would be pretty cool.
That's
And
very exciting.
and
Very.
the light's just the beginning, of course, because then you have a tiny wee plasma. It's like you can imagine if. Excuse me, I got to turn off my chimes here. They're just a little too much chiming going on in the background. There we go. You can imagine if this was that tiny wee bubble that we looked at earlier, if this was that tiny wee bubble that's actually only you can't even actually see through that, hardly. It's so small in between these tips here that it's virtually impossible to see through with the camera. However, trust me, you can see through it, and it's just basically about maybe 300ths or 500ths of a millimeter. I think that's about 50 micron or something like that. And I think the bubbles are even less than that. I think they're down around 5 micron. In any case, they're small, tiny wee bubbles. Imagine if this was that small, tiny wee bubble, and we're able to actually create it by shaking instead of having sound waves. And perhaps there's other ways of doing it other than sound waves. We could look at other types of waves. All that's required is the interference of waves to set up that standing wave. So perhaps, well, the thing is, once we have a plasma started, basically it's a laboratory to experiment with. This would be inside our vessel of plasma water. Makes sense. So it's a plasma within a plasma to start with. And then once we have that high temperature action going on, then we can introduce different particles into the situation, into the environment, and change the conditions. And then perhaps if we introduced lead gans into that high temperature, intense environment, maybe it would create gold. Entirely possible. That's where isotopes can change very easily from one element to another, because the atoms and the electrons and protons, neutrons are being broken up very easily. Nothing withstands a plasma, a true, strong, powerful plasma. It will rip apart any atom that we know of. So I think that it would be a fun thing to play with.
Plasma science rocks.
Yeah.
Rick, before you go, use a magnet to attract your Dremel shaft to the glass and then slide it up and pull it out the hole.
Boy, there's a challenge I'll take up. Thank you for that one. Let me see, what have we got for magnets here? I got so many. Oh, jeez.
Wow, we got a brand new carnival game.
Yeah, I'll get my most powerful magnet out and see what happens with that.
Well, that'll just pull it right through the glass, dude.
See, this is, for those who don't know, I store my magnets on the ceiling here, on all the metal pins that hold the ceiling on, and it's all through the whole room are all these super magnets. And here's a big honking one here, with a couple of other smaller honking ones attached on. So, but stainless steel shaft, I'm not sure. Yeah, it doesn't attract.
Lift your ball up and go to where the shaft is. Don't try to pull the shaft to it.
Oh, it's only attracted to one end of the shaft.
Right, that's what you want. You only want to pull that end up through the hole.
No, that end is the end that's
where your thumb is. Where your thumb is, up through the...
Yeah, you got to say, well, you got to realize that it's only attracted to the big end of the shaft, is what I'm saying.
One, you can't go to that.
So it's going to be a little trickier to manipulate. No, I'm going to have to be inside the sphere for that one, I think.
Try a softer magnet then, because you want the other end. Get it, take it.
Yeah, you can try it this way. Whoa. This looks like one of those games you play at the circus that I never did win. I'll just have to line it up and drop it in.
Is that
How good?
shaft
How good is your 3D?
If that shaft is steel, you should be able to grab it.
No, it's not. It's stainless steel. There's no magnetic action with it.
Okay.
Actually, there is a tiny wee bit.
Well, that's okay. Then put your thumb over the hole. Yeah, take it. Turn the
Okay.
hole to the magnet. Then
Yeah, like I say, there's so little grip. It won't hang on to it when it's upside down.
that
No,
balance.
I can do this in 30 seconds in my sink. I could be here all night with the magnet. Yeah, maybe if I set up 3 magnets and had it triangulated and put it
It
in
was
the.
it was very cool to see. Thank you, Rick. And yeah, it's a good idea. A whole
Well,
where you,
I'll be right back in a second here. If somebody wants to fill in with a bit of conversation or sing a song or something, I'll be right back in a minute here.
Yeah. I'd like to
I'll
ask.
hum in the background if I have to, but no, I'm going to turn my.
okay, Mark, what do you have for us? Woohoo!
Well, what? You can talk for a couple of minutes here, Mark. I'll be right back. Okay, I'll fill in for you, Rick. That's fine. Because this is just a follow-up project for everybody. Because everybody knows the bottom half and the top half. The top half was the just the gans water with different ganses in the. I didn't have ping pong balls. I found little eggs, little Easter eggs, and I just filled those with the CH3, CuO, and CuO2 or CO2. But now I just thought that it would be a fun idea just to see, because what you see on the bottom there is last week is what I showed you that was in the ice. If you remember what it looked like in the ice, that's the one that started from that had the outside pods, and what it did was it brought the energy from the bottom of the ice towards this up from the bottom towards the center and out to the top. And I have what you see, the dark part is a nano-coated copper pipe with gans material inside. And what I thought was it has a center core material. And like I said, you could see the energy that it was flowing from the ice pack from the outside to the inside. The bubbles created, even on the wires, started to draw the energy from outside towards the center core. So what I just thought this would be a fun idea to just try to pick up some fields as this spun. Now, I'm a little worried about going 10,000 RPMs. This isn't built for anything like that. And what I did was I just set that, it's just a plastic, 2 plastic bowls, one on top of the other with a nano-coated copper wire on the top and a nano-coated copper wire submerged in the water with just a couple of nano-coated wires in the water just to create, to allow the field in the water to be created. So what I thought was, since the middle core was drawing the field inward, is it enough to create a whole field? I just put this together tonight because I finally thought out the center core and everything, and I just thought it would be fun to look at, how we like to see things move and groove. But the odd thing about it is that you can see my electric meter on the top. The meter is the plastic sphere on the top isn't connected in any way to the
ball or anything underneath. There's no wires, there's no connection whatsoever. But it's holding about. I have my meter set at 200 milliamps, and it's holding about 20.1 milliamps. 18, 21, right in that range, and it's been solid for the last. Well, it's 2 o'clock now, so I've had it on for about an hour and a half, and it'll hold that range. And I was just wondering why it's picking up millivolts for no other reason but just sitting on top of that. Maybe somebody that knows about fields and or why millivolts are created. Because on the top ring, it's just 2 nano. It's an in and out of a nano coated ring on the top, and just a couple of nano coated wires. One in, one out. It's a complete wire, so it makes a complete circuit through your electric meter. Your reader there. Does anybody know why it reads that? Maybe John might know.
There's could be a number of different things going on here. The first thing that came to my mind is you've got a field that's being created that's permeating the circuitry of your meter. And the number, what we've seen with the testing that we've done is the numbers don't mean anything other than a yes or a no. Either you have the field or you don't have the field, or you can see the changes in the field because the numbers change. But the numbers don't really mean anything. There's no the value. It's not a volt. It's just 20.
Okay, it's allowing you to know that something is there.
Yes, you've got an interaction between a field and a conductor, in some respects. Now, because we're dealing with nanomaterials and we're dealing with plasma, which converts at the point of need, you could have a 300,000 volt potential field there, but because the meter only wants 20 millivolts, that's what it's reading.
Correct. Okay. Well, like I said, I don't know. We're just having fun with these things, and I thought, well, just to complete this portion of my thought process of this part, the spinning of the pods, and I just wanted to see if maybe that after a while that if there was enough field to move the eggs up top, in the water, and I thought maybe the vibration would move it, but the vibration really hasn't moved it to the point where there's spinning in the ball. So I was really hoping that that there would be enough fields to start, because there's like I said, there's a couple of different types of gans in the water, and then there's different types of gans in the balls. I have them all different ratios, so that there is a potential difference between everything that's in that sphere. But like I said, it's only been running for an hour and a half, and down below there's different potentials as well.
Yeah, you've also not got a tremendous amount of nanomaterials there to collect and allow the fields to build upon themselves either. So you may have results, but it could take quite a while.
Yes. Well, I have nothing but time.
Did you get any farther on what we were discussing earlier in the week?
Well, actually, more developments have happened since, and I'll have to set it up. I taught myself how to at least set my camera up, and then once I get to it, then you can kind of help me talk me through, focusing it, because there's a lot more to focus on than there was just a couple of days ago.
All right, no worries. Looks like Rick is pretty much ready to go again.
Yep. It's all yours, Rick.
Just get my thing together here. So this is the wacky setup. I'll put my safety glasses on for this one.
You don't have any way to actually clamp that more to something solid.
Well, I was trying to do that, but there is a flexible, I've got a flexible mount in here. This is actually a suction cup that I glued onto the end of the ball. And I put the brass tube through the suction cup. The brass tube's about this long. And glued that into the suction cup. Yeah, I think it's ready for testing. Close enough, as they say. And yeah, I just have to hold this part. So that's so I made this so that this fits inside my bulletproof chamber, actually, so I can actually put a ball on there and put it inside the square plastic polycarbonate test chamber, and then run it at very high RPMs and check for explosions and things. So it's a test rig, basically. I can also set it up on my lathe over there. Actually, that's the way I should have it set up right now. But I wanted to do a desktop thing and see if it's actually possible. So let me just try it and see what happens here. Whee! Here we go. Quite a vibration. It's probably pretty noisy. I think it's I'm going to turn down the audio in the live stream a bit because it's obnoxious. Trying to get it to actually create a vortex inside, and it's difficult. Okay, well, try it sideways.
Yeah, you got a lot of mass and water and not a whole lot of friction between your ripping and
Okay, well, that's interesting. It's actually created a little tendril in the middle. I can't get that big bubble to go around, which is, I thought I'd be able to get it all rotating quite easily, but no. But there is a tendril in the middle. Let's see if we can see it. Well, I won't subject you to more noise that way, because I thought it would get it spinning much easier, or much more, you might say. Well, now I've got something that can self-rotate around my desk. I bet if I put it on the floor, it would go around in circles. But it would be squirting water out as it goes, unfortunately. Okay, well, that's interesting. Because I thought that little rubber thing in there, I thought that that would undoubtedly create a major vortex there, but it wouldn't hardly do anything. That's amazing. It did create that central tendril, and I was able to have some control of that in terms of when I slowed it down, it became more of a series of tiny wee bubbles, and then I sped it up and it was more of a tiny wee tendril. And at the same time, it didn't bother that bubble at the top. This tendril came from somewhere else. It seems to pull the bubbles off this bottom plate here, which often has a few bubbles sitting on it. Does there now. So interesting. It's not quite ready for prime time, as they say, but it was a kind of interesting experiment.
Looks like you inspired Lee. He's holding up something that's looking pretty
Oh, you already
interesting.
made one that does work? What do you got? This is going to fall down if I allow it to. Just a second here. I'm going to put this somewhere over here where it's...
You got a little spring clamp you can clip on that?
Yeah, I need something like that. I think that'll work. Stay. All right, Lee, you're holding something up there, and so I got to get you all spotlighted here and see what's going on. What have you created?
I was nano coating my car magrav wires, lead wires, and I had this plastic bottle in a crock pot.
Oh,
This is a type 1 plastic juice bottle, and then I had caustic soda inside the juice bottle to get to steam the wires. So type 1 plastic doesn't go mixed well with caustic when you heat it up in the boiling point.
Yes, they actually use caustic to break down bottles like that, because when they're put into landfills, they last for 10, 20, 30 years or whatever, and that's not good for the landfills. So they have a process now where you basically have a barrel of caustic and you throw a bunch of these plastic bottles in, and it gradually dissolves the plastic, and then you can create fuel from it, actually, because you've got the CH stuff. It creates a sort of a methanol fuel, and you can make I think you can make a diesel fuel out of it too.
Of course, the first time I tried, I just had caustic in the ceramic pot for the crock pot. And of course, caustic eats ceramic too.
Oh yeah, I didn't have that much of a problem with my crock pot. Well, now that you mention it, yeah, it does eat into it after a while. Yeah. How long have you had it in your crock pot before you started noticing the ceramic being added to the mix?
Well, I probably used it for about 2 weeks, but then it was all encrusted with dried caustic, and I had it sitting off to the side with just water in it trying to dissolve the caustic, and probably sat there for another 2 or 3 weeks. And
yeah, that'll be
then
super.
the ceramic started to bubble.
That'll be super concentrated caustic as well, about as concentrated as it could possibly be as soon as it has the liquid in it. Yeah, I had the same experience, and a couple of crock pots have kind of bit the dust that way. I wonder what the ceramic, what that might add to the mix as such. When you know, it must be part of the equation in the nano coating process. And what is ceramic exactly? I guess it depends on the ceramic. What porcelain in particular is what clay, carbon-based stuff, but it's particular. I wonder what it would add or detract from the equation.
Don't know. So is there a plastic that is better to use with caustic in it, like The light crystals actually come in a type 2 plastic bottle, but of course it's not liquid, it's just the crystals. So I was wondering, instead of using the type 1 plastic, maybe I should find some type 2 plastic bottles to use, or does anyone know what's a good thing for bottle for liquid caustic?
if you have a lab supply area or a lab supply business, you could probably get really heavy walled, high density polyethylene bottles. They would survive significantly longer.
Yeah, I was going to say probably polyethylene. I think it's polyethylene bags that the caustic comes in. So I don't think it eats into polyethylene, but the what's it called, PET, or at least the consumer drinking bottles. I had a picture. I don't know if I can find it here. I'll try to find it, that shows the effect quite dramatically. I'm just not sure if I can get it into my program.
I'll just have to back up about 2 minutes and see Lee's catastrophic failure.
Yeah, that's one.
It almost looked like there was a function of pressure there too, Lee, that blew that bottle out the way it cracked.
There shouldn't have been, because I mean, there's lots of gaps between the wires at the top. Like I got it taped at the top, but there's lots of holes up there.
Yeah, that's what I wanted to show. Is it's actually the opposite of compression.
It's gone brittle.
There we go.
So that's the bottom of the bottle.
Okay, I got a picture to show here that's pretty dramatic representation. Here, let me share the screen here. Just get it up. Just a second here. Let me see. Get this clarified.
Halfway along the wires, I sort of nicked it to see if I was getting the black coating 3 feet out, and then I let them just hang off the workbench, and then the caustic actually got sucked right through the wire and was dripping out where I had nicked it. So the whole inside of the wire is got liquid caustic in it there.
That was just from the capillary action, not pressure, right?
It was probably like a siphon, because this was the low part in the wire, so or something. Could be capillary action.
Okay, well here's my example of what caustic does to a Coca-Cola bottle. These were both exactly the same size bottles.
Oh, Rick, that's just a little thin strip on our screens.
Oh.
We're only seeing the right-hand
Let me
side
try
of that
again.
window.
Let me try again here.
There we go.
Okay. So yeah, this was, these bottles were, it goes better the other way. These bottles were both exactly the same size, and as you can see, it's rather dramatic as far as the shrinkage goes. The whole bottle shrunk about, well, it's probably 30% or something like that. Shrinkage.
That's amazing. And that's caustic?
Yeah, that was just from caustic inside the bottle. So, yeah, eventually they dissolve, and well, they basically, if you think about it, it's taking off the hydrogens out of the plastic, and probably some of the carbon as well gets dissolved.
Is it okay to store it in glass? Glass jars?
The caustic?
Yeah, liquid caustic.
Liquid caustic. I believe so, but it does etch in somewhat into the glass. I believe it forms silicon dioxide on the inside of the glass, just really close to the glass surface, which is actually an interesting substance to investigate as well.
There we go. Okay.
So, I mean, it's going to be different storing it in plastic than in glass for sure. You're going to have a different effect when you go to use the caustic.
Right.
But how much of an effect is it, going to be? It depends. Like if you to look at the background of this picture, you see the blue substance in the back here. If that was some blue with caustic plus blueness from copper dissolving in the caustic, then that will affect the nanocoating process, possibly for the as it might be an advantage, it might be a disadvantage depending. But I think that material heated up with the copper already in it could produce good results. It might tend to have a more pure nanocoating result because the copper would tend to replace everything else in the water. But that is one of those experiments that would have to be tested more thoroughly. The point being that caustic does pretty amazing things to cola bottles and drinking water bottles.
It kind of messes up stainless too. My stainless steel 5-pan is now copper clad on the inside.
You're copper clad. Now, is that from the copper being deposited, or you mean the stainless got removed from the copper or something?
No, it's a like a $200 solid stainless, big, heavy, high-end frying pan, and the inside is now copper.
Oh, neat. Yep. Well, there are experiments you can do with like making that blue copper sulfate you see in the background of this picture, and basically I think you just dip in, is it zinc or nickel? That all you have to do is put something in it like that, and it will start to copper plate it. Just because it's that's the dynamics there.
I would think probably nickel. That is a component of stainless steel, so that would explain why the inside of my nice shiny fry pan is now kind of brown.
Yeah, that makes sense. I think they copper plate things first in order to nickel plate them. So nickel and copper would both be attracted similarly or close to each other.
Hey, Rick, the plastic bottle that I have that's working real good for about 4 or 5 months is your ketchup, not ketchup, but mustard. Your squirt bottles. You turn upside down, squirt it out. That's stuff that I've had one that's half full of caustic. And it's no problem. It's holding real good.
Okay, as long as you remember which side's up and which side's down, I guess. I find those new ketchup bottles confusing. In fact, I refused to use the one that was the upside down one recently and switched back over to the old style ketchup bottle that I can rely on because I know where to hit it.
Yeah, not the ketchup, but the mustard. There's something that in the mustard that would be the same. The plastic is holding up for gans.
What's the recycle number on the bottom of it?
I don't know, I haven't looked. But I've used several different kinds of the mustard, different brands, and it's all the same thing.
Okay. And sorry, are you talking about holding gans or holding caustic?
Oh, yeah, that's right. Okay. Yeah, I got mixed up because I couldn't hold the Gans water even in the big whiskey bottles. It all dripped right out. Yeah, I was holding Gans. Sorry.
Okay, I see. Right, a little bit different situation, but it's a good topic to discuss what is an appropriate container for GANS material. Okay.
The ones that worked the best for me so far have been pickle and relish jars. The water doesn't seem to leak out. It looks pretty stable.
Pickle and relish jars. You mean like the standard ones for pickling? Pickling, yes. Okay, got it. So that'd be
Well,
half liter or something like that. The ones about the
yeah,
age.
274 milliliters or whatever it is. They're not that large. I've got some stuff in the small little jam jars, the little mason jars, and
Right,
they seem
that's-
to work pretty good too. But
Yeah,
the ones
that's
I have
where
in
it is.
plastic containers, the water seems to disappear.
I found that with the little corked containers as well. The ones that have a cork on them, they're just small. Usually, some of them are tinted even. You get them at a dollar store, and boy, they don't work very good. They do evaporate. In about 6 months, all of your liquid will be gone, and you'll be down to dried gans. Yeah, those ones. They're great if you want to allow the water to evaporate and not get contaminants in there at the same time. So that's a feature, not a bug.
This bottle is probably.
Oh, sorry, let me get your video spotlighted there because it wasn't and people can't see it. So there we go.
Yeah, this bottle's probably 5 months. It's been sitting like that.
And was it topped? Did it have more liquid in it before?
No, I haven't. It's been sitting on the shelf. I haven't even
Really?
touched it for quite some time.
Maybe mine being
And-
beside the stove makes a difference.
That's these jars. What I was talking
Oh,
about.
okay.
Sorry. I've had that. That's been in there for probably 2 years.
Concentrated like that.
Well, I've been using it. I fill it up and I drain it out, and I constantly use it.
Okay.
But I never have a problem with it leaking out or getting on the outside or any of that sort of stuff.
Right on. Yeah.
These little plastic bottles, which seal up really good,
Uh-huh.
surprisingly enough, but the water disappears.
Huh. Okay. I see what you mean. Interesting. Great lighting effect there, John. Holy cow. Very dramatic.
Well, I've only got one. I only got one soft light in here. If I had the other one in, it would be nice and even. It's in the kitchen right now because I was doing some work in the kitchen.
It's interesting lighting. It's very effective if you're doing a movie or something. We are doing a movie. It strikes me. Okay. Let's move along then. Any other questions, comments at this point? Or shall we move on to the next great and wonderful thing, whatever that might be? Did I hear Denny make a comment earlier? I thought he said a breaker in there, but I could have just had a hear. I might have had a hearing glitch. I'm not hearing you, Denny. I saw your microphone on.
My audio.
Oh, there we are. Was that your breaker that broke in earlier?
Yeah, I was going to say, I have other things to show, but it was back there when I asked for breakers that when we're dealing with gansing the inside coil of when you're placing one coil inside another coil, you may have to adjust the diameters so that it makes it easier to insert one coil inside the other, because there's no rule says that they have to be a certain size. You may have to adjust it because what you're trying to do is fulfill your purpose. If you want to put a gans on the internal coil, it's so hard to describe these things, but let's just say that you've spun that coil on we're not talking about the magravs where you got the outside double coil and an inside double coil. I'm just talking about the double coil. But let that be said. I'm not going to harp on that. This is what I'm going to harp on. let's see, do I have video? Yes, I have some video. Remember I said that I was getting these tetrajoints?
Yeah.
Are you gonna, do I have to pin this or do you pin it?
There we go.
Okay, so these tetrajoints have 12 little joints on them. There's 3 that comes out here, 6 that goes out here, and 3 here. But of course, you can turn them other directions for your own purpose. This particular purpose is a star formation, and I pulled this together just now from some different parts. But let's get this up just a little bit.
And is that like half-inch
Yeah,
pipe?
that's half inch. What I do, let me see. My next one has a half inch inside the thick wall. The 3/4 will fit over the wall, and either I can just cut it so I can strengthen these up. And there's a combination of things we can do, but I'll just leave that for another time. Let's see here. I'm in the process of making a larger one over there, and I don't have the legs on it, but everywhere you see these spikes coming out is a hub. Now let me put this back. I'm sorry for the commotion. So every one of these things is a globe. There'll be a globe here and a globe there, and they're different sizes. Okay, now let me share screen for a moment. And this little creature here is what goes around those spikes that come out. Let me annotate here. Let me see if I know how to annotate still. The tetrajoint, it sits in here and goes to, let's say, every one of these. There's one there, and there's one there, and there's one out there. So the point of my particular principles here is there will be 3 sets of these hoops that goes around a tetrajoint. And the whole point of the tetrajoint is to draw plasma energy to the center of the hub, so that I can, and that's the process here. Now just let me stop share for a minute. So when you see this hub, this right here is a smaller version. This just happens to be some pieces that I had laying around. It'd be a longer, it's like that one over there that has, those are 9-inch tubes that they will be designed so that I can stick a health pin type set of coils down that tube so that I can direct the plasma flow to the center of the hub. And each one of these, like I showed you that funny little tubes that went around there when I was screen sharing, there'll be 3 sets around each hub. And I have, this is for the flight system. So I ran out of parts. Friday, I get a few more coins and I run in and finish this thing. But that's not finished, because even on the outsides of these tubes here will be a set of coils, and I mean a double coiled, an internal and an external coil, and I will be wanting to put different ganses on the internal and the external. All my ganses, I work outside and everything has gone below 0 and all my ganses are frozen. I learned a couple of important things that way. that I probably don't ever want to work with liquid plasmas inside my tubes because they'll split my tubes. And but this is pretty interesting. It'll take what the connector that Lee showed tonight might work very well with these, because let me see here. This hub here will be smaller than that hub. This will have 6-inch joints, and so everywhere between these joints and between each hoop that goes around here, there'll be a coil, and then a coil, and a coil. And the reason why I want 3 hoops is that I'm after the skin effect. I'm after the variances between each coil, and so that's the principle of this thing. And I just thought I would show it at this stage if there was time tonight. And the tetrajoint that I had made cost about $7.80. The copper, 1/2-inch copper you put in there, and I have for the flight system there will be 16 globes. So this right here is just a mock up to where if I was to do a smaller unit, they would have, and this is just my perception. It has nothing to do with what's correct and what's incorrect. And so it's experimentation, but it's also an experimentation trying to apply all the principles I can so that I can get the health impact, the food impact, the flight impact, and also being able to create the fields that will house a person in a spaceship. So that's the direction I'm going with this experiment.
Pretty cool, Denny. Couple of questions. What would be in the center of those plastic units, at the very center of them? Is it hollow?
They're hollow, and what I intend to do is to have them made out of brass, but that takes a little more time, and I haven't found somebody to make them for me out of brass. And so in this particular system here with this tetrajoint, I'll just point to these because they're stable. This tetrajoint, they will be inked or painted with a nano-coated copper filings and nano-coated particles that come off of a nano-coated copper surface. They'll also be coated with gans, and so that shouldn't be white when I get done inking it. Of course, where this goes together, I will probably have a little piece of copper so I can keep the strength of that being plastic. So these were the first purchases. Now that I got what I want, I've ordered up a thicker wall. So the inside diameters is 5/8 inch, because that's the outside diameter of a 1/2-inch copper tube. Then the wall will be an 1/8 inch thick, and so that the outside diameter of the tetrajoint will be 3/4, and that's what this inside of this 3/4 tube will fit over.
So then you can put 2 tubes, one concentric to the other, if you want.
Yeah, one of the thoughts we had, as we've talked over these things, is you put a slice in this one, and then you put a slice in the other one, and you don't use coils. You just use the the slice, but you could put a coil over the top of them.
Yeah.
You may not want to have you could put an internal coil too. That would be a technique, because the only reason why I'm keeping them solid on this particular experiment is I'll fill it with I will use dried gans in there as well, with some caustic, a little bit of caustic, but I won't go liquid plasma, because I don't want to I'll be outside in the cold and it'll freeze the stuff and it'll split my copper.
Yeah.
And so because it's too big to sit unless I'm doing a smaller version. And you can do a smaller version instead of using 1/2-inch joints. You can get them down to just be the size of a wire, you know, and so that the wire goes in there. I don't care if you're using say 10 gauge or 8 or 6 or 4. 4 is just a little under 1/4 of an inch. And so that can, and it's really stiff, a 4 gauge is. And so you could use that as instead of copper tubing, and then you could reduce the size of this. Of course, you would reduce the cost of it too. A cost here for me on a 10-foot piece of 1/2 inch is $12.68 plus a 6% purchase tax, sales tax. So that's the cost of the joints and the cost of the copper are about the same. About $130 a piece. When I'm done with the full system, there will be 16 joints.
How much did you say the joints were?
They were $7.80. I'm getting a quote on. I'm getting a quote on the thicker one that I want. And
is that custom made from Shapeways, or is that?
No, this comes from. Let me think of the name. It's a thing. Well, let me see what I can.
Sounds like a Chinese outfit, anyways.
No, it's in Michigan. Thingsmith. Thingsmith.
Thingsmith. Oh, I thought you said.
It's got an S on the end. It's Thingsmiths, like blacksmiths, but it's Thingsmiths, and they don't have metal, but.
Well, is this your
does.
Is this a custom design that you came up with, or is this something they have in stock that they keep? Is this a normal thing?
I had to present them with the CAD drawing.
Oh, okay.
And lucky for me, I found one.
Yeah.
And then to make a smaller tetrajoint so that I can use wire instead of copper tubing, and so I can decrease the size, because I like to be able to get that down to where it would fit in the bread box. Is it bigger than a bread box? But I like to get it down.
There is the 1/4-inch tubing is quite readily available as well. You might consider
there is.
that.
So in order for me to get these tetrajoints redesigned and reduced to those smaller size, it was going to cost me $196, and I decided I would spend that on copper tubing instead. And at a later date, when I'm wanting to do a smaller one, is it providing that this system here has any value. You know, it looks like it would have value from the different principles we've learned from Mr. Keshe. So, and my way of thinking isn't the only way of thinking. Somebody can look at this and see that they have a better idea. And
are you going to nanocoat them?
I'm going to nanocoat it all, but you see, when I'm first designing this and put it together, I'm not ready to nanocoat.
Okay, see, you're on the designing side of
Yeah,
it at the moment.
yeah, I just got my joints here last week, last Friday.
It's very beautiful. Those tubes are going to allow you to add whatever you would like to add inside it. And then if you nano-coated, one side would be nano-coated and the inside wouldn't be. And then you'd be adding perhaps plasma water inside it. And the
Well, I probably won't
possibilities
put.
are endless, honestly. It's
Yeah,
very nice.
there's a lot of different value, different ways that people will look at this. If I'm taking it outside in the cold, I'm not putting the plasma water. But if you're keeping it inside, then I would you don't have to worry about it. You could put plasma water in there, or plasma, what is it, liquid plasma.
Sure.
And so, but
When you talk about a spaceship, what did you mean by that? Like, how are you going to achieve that goal?
well, right now I'm getting the frame ready. What happens here is I will have in my other one, you can see that that I have. Well, let me just lift it up a bit. The
Wow,
legs are
they're very big, aren't they? Oh, I didn't realize this.
the legs are not on it. They'll be about 36 inches long, and so that I can lift. And this particular one here is down in each corner.
Yeah.
And then around each one of these is 6-inch tubes. These are 9-inch tubes. Then around the smaller ones, and these are the directional ones that go around here are the directional, where they had it from the Philippines when they did Marco, he had a 6 generator, a 6 reactor and 12 reactors, 6 and then 12. Mine is 3 and 9. And so it's a deviation from the norm because that's the way the joints made it work. No, I can't. I can possibly do a 6-12 if I do it just a little bit different, but it's difficult.
Yeah, Denny,
yeah.
if you get a hold, I'll send you my email on a private message in Zoom here. If you can send me the existing CAD drawing that you have, I'll generate the smaller systems for you.
Well, just give me a moment here. You see this? Let me share screen on this, and I'll show you something.
Hi, Denny. This is Mark from Detroit. Did you say you bought those from Michigan?
Yes, I did. This thing, Smith.
Well, I'm in Michigan. I'm in, around Detroit, Michigan, and I'm willing to collaborate with you if I can help out in any way. I'd be willing to chip in, and if John's willing to design it, I'm willing to put my money up in.
These little joints aren't too expensive.
Whatever way we can get this thing going, I'm here. If I can help get.
I just introduced this so that if somebody else had ideas, they can do it. Now let me share screen here for a moment, and I'll show you something, John. That's not what I want, but possibly what I want. Can you see that URL?
Well, we see a picture of your joint there and a green one on the right.
Let me take this URL.
We can see the URL. We can see the URL.
Let me put that in the chat. Let me stop screen. Let me put that in the chat.
Yeah, just I've put my email in there.
This is not a private thing for me. It just doesn't make a difference. Anybody can use this. This guy that created this particular CAD drawing, it's a GrabCAD. He put it out there for free gratis.
Yeah,
And-
I sent you my email address. You can send me a little a series of notes about what you're looking for, diameters, wall thickness, lengths, that sort of stuff, and I'll generate your smaller hubs for you.
Okay, I'll do that. Well, do you have a printer yourself?
I don't have a printer yet. I'm working on it, and I'm hoping for some more donations to be able to pull this off. But I need about $1,200 to get the printer and up and running, and enough material to actually do something with it.
Okay, let me see, I can save this. I'm trying to get your, all right, so I'm out of screen share, aren't I? Okay, so anybody wants that grab CAD, there it is.
All right, I'm gonna show you a couple of things with what I've done with it.
Did you put it in the chat,
It could be,
Denny?
I thought I did.
Oh, there it is. It came through from John anyways.
Yeah, no, it's Zoom. When you send someone a private message, it automatically sets yours to private. So you have to set it to, if you want everybody to do it, you have to change it. And
So
lots of people miss that.
You got that then, John, you put it in. All right.
Yep, everybody's got it now.
And so great. So I don't need to be on the screen anymore. Anybody else wants to take over? If you have any other questions, that's fun. Just a minute. Let me get back to where I need to be. So yeah,
Okay.
I'm done.
Thanks, Denny. Really cool. Any other questions for Denny? And before we go over to Alper here.
That's wonderful. I just would like to add to the knowledge and perhaps share it and get more ideas from Denny, because it's wonderful what I've seen there, and it's really really creative. I love that. What I've noticed with this, when you hit a high field interaction, an intense one, it changes its sort of cycle, bleeping, whatever.
Wow. I've never seen one of those do that before. Does that do that with other electrical circuits or just with this thing?
Just with this creation that I've done. And
wow, that is really something.
It's really intense here, and it jumps onto me. And there's ionization in the air. You can smell it.
Well, do you have any? Is this hooked up to electrical? This maybe you have.
Yeah, it's just.
This is one of your lifter designs. It's hooked up to high voltage, is it, or?
That's right. It's a lifter hooked up to high frequency, and it comes from. It's just I rolled a copper wire around here and attached
I see.
one to the surface of the aluminum foil, one around the magnetic cable that goes around it, and
wow, that's really neat.
that's quite intense. So what I've gathered, if I mean, this is one way of doing it. There are millions of ways, perhaps. With playing around the field, trying to create the intense interaction within the field. At the moment, if I apply a high frequency electricity, I see it with my own eyes. But that also doesn't mean that it's not happening when I wasn't applying it to. There's a unit here. Interaction always happens, and just to be able to see it with my own eye, this is important. with that one, it slows down. With the Tesla coil, it goes faster. It happens right the opposite of it. I don't understand that fully, but this is just one of the experiments that I've tried. Triangles are mysterious. When you apply our technology on towards it, when you just a little bit, well, I sprayed with the caustic solution and to be able to nanocoat. It really is kind of one of a kind. I don't know how to explain what I've gathered the information. Every day is a new invention, new understanding of it. I don't understand why people go out and say like, oh, I created this, I designed this, I did that, I did this. It's just one of a step, and to be able to achieve the whole totality of it, like not a momentary design that you created, because it moves on and it gets another understanding of it, another creation. But the meaning of it, they're all going to be the same until we achieve the ultimate goal here. Amazing. Denny inspired me. I want, I told because of him. Thank you so much, sir. That's all I wanted to say.
Thank you very much. And I wanted to ask Mark one more thing, because Mark was asking something from me, and I was, so yeah, you're there in Michigan, and we can work if you want to get some of these. I'm sure we could work together. If you need me to group order, that's fine.
Yes, sir. That's the only thing I'm after here in America, and I'm in California. I'm happy to share anything that you. I mean, I can add.
I think Denny was talking to Mark, weren't you, Denny, or am I confused there?
I was talking to Mark because we kind of got disconnected there. Mark made a statement to me, and I really didn't get the answer back to him. And so, Mark, do you want my email or something?
Denny, I'm telling you what, whatever I can do to help and collaborate to make our dream come true, you let me know. You just let me know. I'll give you my email so that you can contact me when you feel comfortable.
I have no problem. I'm comfortable no matter what. I'm just, I relax and allow.
That's fine with me. Like I said, you might have the structure and I might have the heart. So between the two of us, if we could gain something between us, I would be more than willing to spend my money with your money together. And if John would put his talent to use in designing it, it's absolutely fine with me. If I have to drive my old truck to wherever I have to go to get the parts and send it to you faster, I don't care. Whatever it takes.
Oh, these are pretty nice people to work with. I'm very happy with them. The thing of it is, at some point, I will want to miniaturize, and at that point,
I just don't want you to stop being like John. You know, John's. We're a family. We've been taught to be a family, and John's a little. It's tough up where he's at. So I'm fortunate. I have a story to tell right now about because I live in Detroit. And everybody knows what Detroit is like. It's tough times, but for some reason I'm making. I've somehow, some way, things have happened where I've been able to afford myself again. So I'm willing to use my money to help whoever can, because John needs some money for wire and stuff, this, that, and the other. So if we all work together to make our dream come true, I think it would be a lot easier. And I would be willing to share whatever I can for our friends in this group, because we've been so supportive of each other for the last year or two that I look so forward to this day, every Tuesday night, I put aside stuff just to make this group session. So I'm just so happy. So I just want to know, I whatever I can do. I have some means, and not much. Whatever happened, I got a couple bucks in my pocket. You know, John said I need $8 for some copper, and I said, well, you know, come on, let's help each other. We're gonna help each other. So that's what I mean. If I'm in Detroit, we got the joints. If he can make the little, if we want to go small, if I can help, I'm gonna help. We're all gonna help each other and get to the point where we need to. That's the only point I was trying to make. So, you know,
just to add a little bit here on the 1/2-inch tubing, since you're probably get the same price. I got this at Home Depot, and it's $12.80 a stick. And to do my spaceship, it takes 10 sticks. That means all the little tetrajoint sticks, I mean lobes that I turn out, and all the connectors that go from here, all the little sticks that come out of here. That's all of it. It takes 10 sticks altogether to do these things. So that just takes time to save up and do. I have enough to make 2 spaceship frames right now, and so I have enough come Friday to do it. So we'll see. Not Friday, the couple Fridays after it. And so that's what I'll be trying to do. Of course, I won't be getting to the gans and the nano coating yet, because everything is frozen out there because I work outside. And so it'll take me a while, and I'm going to probably test some different ganses and different salt solutions, different like magnesium, like Epsom salts, and different types of salts to make my ganses. So I have to actually think about this stuff over a little bit of time. And so I have time, and it'll probably be in the spring, probably May, June, before I finally get this thing done. Turning the coils to get on all of this will take time. And so I'm not in a rush. I just thought I would bring this portion of what I'm doing to somebody's eye, and then they could take a look at it and see if there was something that they wanted to do with it, and to do it the way they want to do it.
Well, definitely it's an inspiring idea. That's almost like what do they call it? There's kits you can get that plug together similarly with sticks and so on. You can build structures for kids, and it's great. I love the idea of the copper tubing, especially if you can put a copper tube on inside another copper tube and have a series of them all nano-coated. That seems like a winning combination to me.
Yeah, you could probably put a 3/8-inch tube, outside diameter tube, inside the 1/2 inch as well, so you could set up with 3 tubes.
Yes.
And I'm looking at down the road that this will be made out of, these joints will be made out of brass. And so that's providing that I get some kind of indication that this is a workable idea. I first have to figure out if this is a workable idea. I have to figure out if I'm directing my plasma toward the center, that
that's the thing. I would tend to not go with the brass in terms of now you have these separated sticks, as you call them, or the struts for this. They're all separated by what's normally sort of an insulator, And if you nano-coat it, it makes it more like a superconductor. It makes the whole thing superconducting. But if it's brass, then it's all, the matter level all connects then.
You would nano coat that. You would take that brass and you would nano coat it.
But would the parts that slip inside, are they going to be a matter level connection, or will they be a nano connection? That would be difficult if they are jammed
It's
in.
going to be difficult to figure that out. And what I do when the joint is a little too tight, and what I will take, and I don't have one shown here, but I will grind it down so it fits, slides in real, and so there's enough play
And
to
and then
grind it
maybe,
down.
yeah, perhaps the interaction between the two nano-coated surfaces will produce a special place in between them there. Yeah,
They're
different
going to get
materials.
they're going to get crushed. The nanocoat's going to get crushed.
But then it'll tend to grow back if it's got some space to do so, and a bit of caustic thrown in or whatever. Just give it a cloth with a bit of caustic as you put it into the socket, maybe, or something. In any case, it'll be interesting, one way or another, to see what a structure it would be made out of brass for those pieces. It would be quite spectacular, that's for sure.
It's a thought. It's just one of those thoughts that come to you. So, but I do want to nano coat these. I do want to paint them. I may even put some graphene coat into the maybe ink or paint, whatever you want to do. So it's and gans it. So that's the easiest way I think I can apply gans to the plastic, if I can get it to stick. And I think I can get it to stick. So I'll have to do tests there to see what kind of surfaces. And of course, I don't know everything, and so I have to experiment.
Yeah, I would think if you're going to be mixing nanomaterials with a type of paint, you'd probably want to go with a natural source paint, something like a spar varnish, that's made from natural materials, not synthetics.
You may want to go with UV resistant medium as well, because it might be that those joints will weaken in the sunlight, I'm thinking.
I'm gonna cover those joints with copper. That's going to be this is going to be covered right now. The way I made them, because this was my first attempt. Now I saw what the manufacturer can do. We had gone back and forth, and I was lucky that I got what I got, and so the afterthought came with the copper after I got these things. So then now I'm working. Okay, so I've got a disturbance in my background. That's my grandson, and so I'll keep going here for a moment. But I will cut off a piece of copper, and I'll slide that over. It's going to be a chore to get all the coils on here. It's just something that's I've figured out in my mind's eye how to do it, but then I have to be able to actually physically do it to know whether it's possible. Because I want coils on the inside of the tube, I want coils on the outside of the tube. I want to direct all the energies to the center of the hub, because I'm trying to get that gravitational to then let me see. I don't need to. Let me do this for a moment. Would you just bear with me for just a moment, please? Where am I? Yeah, this one here. I'm going to go to 3D and load the 3D viewer. so that you guys can see this for a minute. So there's this, and now I want to annotate. So what do I got? I got blue. Oh, there you got red. Okay, around here will fit the copper. So this will be a 1/2 inch inside here. And this right here will be an 1/8. I gotta help him here just a minute. He's got himself in a bind. So just a minute. So that's an 1/8 inch. So this would be from there to here will be 3/4 inch. And that's when that copper pipe will fit over that. And so now my plastic, it really isn't showing except right in here. So now I've got the strength of this plus the copper pipe on the inside and the copper pipe on the outside. Therefore, I think I'm pretty secure with this joint.
Yeah, we can gusset the base of those standoffs as well, and that'll add a tremendous amount of strength.
And on the inside, I have a ridge made on the inside here. Let's just put it up because this is the inside. We can see this. So that when I stick my 1/2 inch copper pipe in here, it's a stop. So, and you might want to do that when we do that with the other one, always have a stop. Okay, so now let me see here.
I'm just thinking, Denny, as you said that gap between each pipe might end up being quite critical. It might be the most important point in a way.
Yeah, it could act like a capacitor.
Yes, exactly. So where the pipes end might be, important, especially in relation to the outside one and the inside one, and so on, and have them all end in a regular fashion like you're planning there. That's good.
And when these hoops go around here, if they're a solid hoop and they can act like capacitors too. Capacitor battery. That's the whole part of it. So there's, you saw the picture of those hoops that I had. And so I'm, or that screen share of the hoop. I'll show you another thing, but I don't need to take up everybody's time. Let me see here what I was thinking.
I think we're quite enjoying this, Denny. It's no problem there.
Let me take this annotating and clear all my drawings. Let me get off of annotate. Let me see. Let's X that so that some people can have some fun with this 3D drawing. So when you get the software, you can see the address, and then plus we got it in our chat. You go to this website and you get this, and then that's what I sent to. I sent this actual thing to Thingsmith, and but I needed what I needed, and half the time when I was talking to him, I kept changing my mind. So I was lucky to get what I got because of the way I dealt with them. I just couldn't quite come up with what I really wanted. And now that I have these samples, it gives me a good chance to know what I wanted.
Yeah, I got a pretty good idea what you're after, Denny. It shouldn't be an issue.
Okay, so there we go. I don't think I need to take up any more time. Let me do one more stop share to just to give a little brief moment here. Let me see if I still have that. There it is. So we were talking about those. Oh, come on. This is what I need. So there's that. And that's how they fit. I'll show you again from another little item that helped me get to this point. Let me stop share. I showed this before at one time. This came from Shapeway. It's the same thing. And so I wanted that tetrajoint because that's what was the inside of this. and it took me I kept trying to do the 3D stuff on it, but luckily, or by providence, I found this grab CAD that somebody had done and had everything done for me. And so somebody else can take a look at this and go to Shapeways and see this, and they may get an idea that that's where they want to put the globes. There's on this globe, there's 4 hoops, and that's how it makes it. Let's go back to this little, just so that it's here. So when somebody wants to go to the there's 4 hoops, and let me see, let me annotate. And so there's 4 hoops. There's a joint, there's a joint. So the way they fit, 1 hoop here goes around, and on that tetrajoint, I'll show you what these hoops do. Here goes a hoop. Oops, there goes a hoop around. And here goes a hoop around. That's my 3rd one. And the 4th one goes around here. On the tetrajoint, there's, actually they call this a, what is it? Something equilibrium, vector equilibrium, because it has this, it has the squares. And so you could look this up and see, under vector equilibrium, and find this. So let me get out of this for a moment. I don't need to go any farther on that. Let me see what I was saying. This here, all the hoops go around the 6 prongs that stick out. So there's a group of 6. There's a group of 6 that goes around there. I hope that shows up. This is a group of 6. So that's why there's 4 groups of 6, and that's how you can make the hoop. There's a, let me see, am I too far? I gotta see if I just maybe need to hold it still. I can probably do it with this. So there's 3 that stick out there. There's 6 that, maybe it's better up here. There's the 6, there's 3 that stick out here, but also notice that there's a 4. And so the hoops would go around all the 6. So that's how you get your 4 hoops. And so I guess that's enough for me. I got to go help Christopher. He needs some help. And so thanks a lot, you guys.
Thank you, Denny.
Thank you, Denny.
Very good.
Thank you.
Thank you.
Get my video up so that I have.
And thank all of you guys too. Thank you very much. I can't do this kind of stuff and think this kind of stuff out without the help of everyone. So thank you guys too. And I've got a lot of resources when you go back through and look at this reactor group. There's a lot of information there that can be correlated between each other. So thank you.
Thank you, Denny.
Believe me, Denny, you've been an inspiration to all of us. Absolutely all of us. Thank you.
Fantastic stuff, Denny. Thank you.
Yeah.
Yep, there you go, Denny. Everyone is giving you a little bit of input there. It's good to know, or feedback, let's say. It's good to know that our efforts are not going in vain. It's amazing, actually, how the one idea will come up and spreads out, and someone else will use that and actually elaborate on it, perhaps much greater than the original person anticipated. Okay.
That's why open sharing or open source works so well. Is you're not hiding anything. You're showing everybody everything, and somebody's going to go, well, that's not the way to do it.
Yep, that's right. It inspires people one way or another. Either they'll say, I could do that better, or they'll say, oh, that's a great idea. I can modify that and play with it myself, and so on. It's
Let me add just one more little principle here that Mr. Keshe is that I picked up, or at least thought I picked up. Every turn of the coil, and when he was talking about Marco's system, that every turn of the coil adds strength and to your system, and he was saying at one time that that little system that Marco put together equates to a tremendous number, equality wise, to magrav units, that there's more strength in that little system. And I think he mentioned it, that it was by magnitudes. So that was one of the reasons that I'm grabbing onto this particular hoop system, because there could very well be more plasma energy that is generated that way.
Yeah, he did bring up in one talk, he was discussing using tubes instead of coils, and he says that if you make it out of tubes and you do it right, you'll be amazed at how much power you have.
And
So,
I think they could be plastic tubes as well.
you can probably make it out of any material you want except stainless. We know stainless is an issue with plasma, but it's just a matter of how do we nano coat the plastic correctly? I mean, does caustic work, or do we need something else?
I think we might be into inking it. You heat it up, and when you put your ink on it, you heat treat the ink, and the ink carries the plasma, and you make your ink out of liquid plasma as well, and so that it'll coat that plastic. So there's a lot of experimenting yet to be done with the natures of ink, and well, I'll see you guys. I'll be okay. Go ahead.
Yeah, I've got something to say about that. That's interesting. I was just reading about in, I think it was 1972, there was a shampoo manufacturer that started a new marketing program, and they had a new bottle of shampoo, and the bottle of shampoo had a special label on it. It was a metallic printed label, and the process they used when they printed it, even back then, they had a plasma type process where they prepare the plastic surface first with this plasma, and then they can print it with the ink, and it bites in and etches into the plastic better. And what was happening is this company started their new marketing program. They got 100,000 pieces of of their product ready to go and started distributing them. And they were getting reports back that people were getting shocked in the shower when they went to open these containers of shampoo. And this was a big thing. They thought it could have just must have been a random event or some strange thing that's going on, but no, they kept getting more and more reports, and so they said they had a special company investigate what was going on, and sure enough, the first time they opened it up, the guy got a big shock about a 1-inch spark coming out of this, enough to make you actually drop the shampoo and so on. There's fortunately no one was hurt. And so what they found out was something happened during the process when this shampoo bottle was going through that plasma process, plus the printing of the metallic ink on top, basically made this shampoo bottle into what's called a Leyden jar. And a Leyden jar is one of the first forms of storing electricity. It's basically a jar with metal on the outside, a metal film, and metal on the inside, and with a probe that comes down and touches the metal, usually with a chain. And you can charge it up. It's a capacitor, or charges similar to a battery, only it discharges rather rapidly usually. And so this is what was happening. It was making these shampoo bottles into an actual a type of Leyden jar, not quite exactly to specs, but it was enough to basically it was like a self-charging apparatus. If you were to touch the outside of it, you would basically be grounding it, and then it would start developing charge separation in the actual shampoo itself, and the positive and negative charges would separate, and enough that when you go to undo the cap, zap, this nice inch-long spark would jump out at probably between 10 and 20,000 volts, and with enough amperage. Yeah, with enough amperage behind it to actually give you a good jolt as well. I mean, if it was a larger Leyden jar, they're known to store charge that could actually kill you. There's enough amperage behind it that it can do that in a larger one. So interesting. Anyway, they had to ended up having a print-on label or a stick-on label that they printed on instead of printing on the actual plastic, and that solved the problem of their customers being shocked. But I thought, whoa, there must be some way to take advantage of that. Why can't we create a container like that's basically self-charging and uses the ambient charges around us and creates charge in the actual sphere, and then you have something to work with. You start rotating that and separating it out and building it, and that's, once you have electric fields that are separated and building, essentially you've got the electric and magnetic, and you've got your gravitational and magnetical, and all of a sudden you've got something that can do something special. And that configuration that you were showing with the rings, which is similar to, say, if we had 3 rings like you were showing there, something like that, or whatever. It's a standard insignia for radioactive things, I guess. You have the 3 rings and so on. And also in what they call inertial confinement fusion, where you have what's some people used to call a star in a jar. You have a jar, and you have a wire shape that is in the shape that we're just speaking of, and that's one of your electrodes. And because of the 3 hoops is very special in that if you put charge on that, especially a pulse charge, then basically it will attract the opposite charge into the center of it. And these, oops, things are falling over here, just a minute. If you were to look at, everything's falling. If you were to look at if this was the sphere, oopsie, and you would pulse the charge on this arrangement, then basically the charges that are out here of an opposite charge get attracted to these wires when they're, say you have a negative charge on this, and it comes as a pulse, so it pulses negative. then positive charges will be attracted to this. Or if you pulse this in a positive charge, then negative charges would be attracted. So in other words, say electrons would be attracted if this was pulsed in a positive manner. And what happens is, this is an electron here that just happens to be in the neighborhood, and suddenly this field gets generated in this apparatus, then the electrons or other negative charges in the vicinity get drawn into this, and they get pulled right toward the wires, but only some of them will hit the wire. Many of them, most of them actually, will go right past the wire and into the center. So if you can imagine, in a similar way of the sonoluminescent bubble and the other forms of fusion we were talking about that way, everything goes toward the center. So you have all these electrons from every angle being accelerated faster and faster and faster toward the center until they go by this point, which is the fastest when it's close to, let me do it this way, when it's closest to one of these wires, it goes fastest, and then it slows down again, but it's still going very fast at that center point. And then it can actually go backwards and even back out the other way and back and forth a bunch of times without hitting that wire, if the wire is relatively small compared to the electron. And it's, you know, some of them will hit the wire, in which case that it dissolves the field. But if it keeps going back and forth, then these electrons have a chance to interact with each other in the center and actually cause a light event to take place with the the action going back and forth, and the fusion events and so on. All of a sudden you've got basically a fusion reactor, and that's what that inertial confinement and star in a jar, kids have actually created. Instead of water, you use a vacuum environment, total vacuum, and have this inside as an electrode, and you can actually create, actually it's not a total vacuum environment, you use some deuterium gas, for example, and you can create fusion without any bad byproducts other than some beta particles and whatnot that can be controlled. Sorry, what was the question there, Mark? I think it was.
It was just funny how your headphones fell off your head. You had the 3 rings in your hand. And your face was within the 3 rings. If you probably backed up the video, it was a perfect. You didn't even try to do it, but then your conversation about this was the central core of everything that you're just talking about. You were the light in the central, just like the thing that you just put in the middle of it. You were that which was in the middle, that you just took your hand and put that ball in the middle of those 3 rings. Your face was in the middle of it without you even trying. Yes, exactly. You had no, the universe set that in motion. Just like you wanted to explain yourself. And I was just sitting here listening, and the rings fell and your headphone fell, and then you put the ball in the middle, and you told us that you were the central core of the 3 rings. Does that make sense? Does anybody?
Yes. Well, I was trying to deal with things at the time because the rings were. These are my special magic rings, and they can do things like link together. They seem like they're linked together, or sometimes they seem like they're not linked together is a better way to put it, because sometimes they seem like they're separate, but actually all of these rings are always linked together. It's just they have the illusion of being apart, but they're actually 3 linked rings, as you can see. And
so good. Ah, woo! I love that. Oh, it's so beautiful. I had to express that. I'm sorry. I just very loud.
The center of the ball.
Beauty. It explains everything, really, honestly.
See, it's all because of magic, and as we know, anything can happen in magic, because with solid matter, you're pretty much stuck. And we know that solid matter cannot penetrate solid matter, so far as we know, right? But sometimes, if we're really lucky and hit the soft spot on the metal here, we might be able to penetrate through solid matter.
Absolutely.
And consequently able to allow it to penetrate.
You just
Yeah,
explain everything right now.
Now you're just showing off.
Yeah. You're just showing off right now.
Yeah, well, if it was anything other than magic, then how could I take this ring, which is apparently a solid ring, and I mean, some people think there's a hole in the ring, or it's behind my hand or something. But I'll take this ring and put it through this ring here, with this other ring blocking. Now this is very difficult. I might need 3 tries for this, but a few tries. It's been a long time. But let's try it. Okay, there's one. Maybe twice. Try it one more time here. Whoa, here goes my headphones. Oh, that was what did it. There we go. So it can be done. There you go. That's the magic rings anyways. And it actually does have something to do with plasma and everything else when you think about it, because that's what we're trying to do, is create fusion from, if we have this as a hydrogen and this as a hydrogen, and normally they're hanging together as H2 hydrogens, but to actually fuse them together so that they're combined somehow and able to interact with each other as a different type of material, or if we could combine other heavier elements linked together, and suddenly we add another hydrogen, and we have different structures, then different geometric structures that become possible, different creations, different interactions. And I think that that's possible to do from our central plasma configurations of our reactors once we get into some of the higher energy modes that enable that to happen. Or even the lower energy modes, because when we work with plasma water...
I got a breaker here, Rick.
Go ahead, Denny, please.
As you were, before you got to having your fun, you're explaining how the different energies may come to the center of the hoops. And so the opposite of, was what I began to think about, is how am I going to get my spaceship reactors to go the direction I want them to go? Now, Marco had some kind of a little shorting device or electric device that he'd put on one to send the energy over to the other. And of course, I don't know how that worked really, because
I think he just had a nano-coated wire, as I recall. Right, that he could take it and move it around to different spots.
Yeah,
I forget where it went.
So my way of thinking is it would be good to have satellites placed around the reactor so that you could turn the satellites off or on. So in other words, little reactors that set out away from the main reactor, and so that you would then power up that particular satellite, and it would cause the reactor then to send its plasma energies in that direction, and then you were able to head out. Because at a certain aspect of the space flight is actually being able to physically travel in your physical body for the pure fun of it, you know. And that's one of the aspects that I'm working on. So that's it. I just wanted to let you know, as you were explaining that it brought about a different perspective of how to get that spaceship to travel the direction you want it to travel. And do it basically mechanically rather than with your mind, because some of these things I want to also figure it out mechanically as well as emotionally. And so that's it.
Well, and also you're using your mind, are you not, to get to that point? So in a way, that is, controlling the growth of the spaceship through your mind right now.
Well, when we get to the communicating knowledge of, as we're starting to change because we really haven't brought that to pass yet, how we're going to communicate different, let's say from right now we're using Zoom and we're using the different things we're having, but when we get to communicate from one particular material to the next material, we use Wi-Fi now, so we're using the frequencies. But as we begin to understand the plasma fields and utilize them for our communication and basically our Wi-Fi, a different kind of cloud will appear. And so that's enough philosophizing for me.
Well, yeah, it's pretty important actually. It's interesting idea there. I mean, if you think about it, our communications are mostly through what we see and hear, like basically it's light and sound when it comes right down to it.
Breaker.
Hello, Breaker, come in. Over.
Yeah, Otis Carr had a flying saucer that they took from Lower California, down in the Apple Valley. And they used a large crystal in the center that the guys stood around and had their hands pointed towards and thought of the location that they were going.
Yeah, I remember reading that story.
Well, Ralph Ring is still alive to tell that story.
Yeah, he's up at Paradise Valley.
Yes, and I, to this point, dedicated everything I'm doing to Ralph Ring. If he went down range like he said, without any recollection or coming back, but knew that it happened, and it had his dream manifest in my mind like he has, to have an RV to be able to travel to every spot on this earth would be a glorious, absolutely fabulous, more than manifesting dream that I could ever have on this earth. And I would my first venture on my craft would be to his house if he's still there.
Now with GPS locator, it's easy now.
I don't even need that. Me and him are connected.
Hey, I'm talking about picking out the location where you want to go to. You want to go to Florida someplace? Pick it out on GPS and then go.
Wouldn't that be a wonderful dream?
Okay, it's there.
Yeah. Our thoughts work much faster than any of the GPS systems even.
Thoughts are the fastest thing in existence.
Way faster than light, when you think about it, so to speak. You think about the sun, you can be on the surface of the sun and then back like that. But it takes light 17 minutes to go from here to the sun and back in that same same interval. We can be there like that. So we're like, what, billions of times faster than the speed of light, infinitely more faster than the speed of light in our visualization.
Yeah, take a picture from the Hubble telescope of a galaxy you want to go to, and you're there. That's what I thought is the fastest there is.
Would you be there at the same time period that the picture that we're getting, like we're getting a picture from a galaxy that's 2
Different part
billion
of time,
light years
you know?
away? Are you gonna get to that galaxy? It'll be like still 2 billion years old, or
Yeah.
in other words, if an alien civilization sends us a message, you know, beep 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 beep, we're out here, hello, anybody out there, and you know, but we get it, you know, 2 billion years later, and then we instantly go there to communicate, to
I'll
actually
let
be
you do
there.
the testing.
Are they going to be still around, I guess, is the question.
No, I just want to go to Florida or Egypt or someplace, you know.
Okay. Well, I mean, we can virtually be there, and you can take tours now that have 3D, you know, camera thing all around. You can move it around and be anywhere inside that tomb or pyramid or whatever you want to be in now. An actual three-dimensional scene you can change and turn around. And we also have avatars in different games that we can become, and we can be in different planets or different parts of the planet or whole different dimensional spaces that are completely alternative than what our ordinary space is. So we do have these means of reaching out. And of course now also with remote viewing is becoming more and more popular, you might say. Some of the files were just released by the CIA in their secret remote viewing program from back in the, I think it was 70s and 80s for that particular program. Even back in the 60s they had it as well. And so that's a lot of that previously secretive stuff has been released. There's several people that are doing courses now on how to do remote viewing and remote reading and that kind of thing. So it's becoming more and more acceptable in the mainstream. It's always been acceptable to shamans and mystics and some monks and others that have taken advantage of this power that we have to visualize, our visualization, our ability to travel to other places and see what's there, basically, and to or to read other places for people, let's say. So
Wonderful, thank you. That's so true. Every bit of it, every word of it, it resonates. It's a beautiful information. We need to understand where we're coming from and what we're actually doing right now. And we're so into our own knowledge and our own expertise and our own world at the moment that we have a sort of put ourselves away from what is actually going on. And when we compare it ourselves with what is going on and what we're thinking and what we're experiencing is it puts us to a point where we are actually with our vision, with our perspectives, we're predicting, we're understanding every bit of the future, every bit of ourselves, comparing it for today's world at the moment. I mean, I just wanted to express where we are, how much further we are from the main whatever is going on at the moment. And all our talks needs to be understood wonderfully, because we're all predicting the future, our understanding, our values, how much it has changed, and where we're at, um, um, and how we can express ourselves. These things are what I'm hearing, and what we're hearing. We're all so casual about it because we're in Mr. Riggs. It's wonderful. Thank you so much, sir. And but we're unbelievably sensitive we are to what is going on around us, and we can evaluate it with our understanding. We're so much sort of away from, and we can observe it freely from above, and what is going on, and understand it. And I just wanted to say that that we're wonderful. Honestly, I mean, I don't want to go into that big time, but yes, we are superb.
Thank you, Alper. I see Doug McDonald has said here that Mr. Keshe said that light years are a fallacy. We see the stars in real time. What do people think of that idea? That's a tough one to get your head around. That actually, when we see a star, we're not seeing it. If it's 2 million light years, say it's even say 6 light years away. That means it takes 6 years for the light to travel from that star. It takes 8.5 minutes to travel from the star that's our sun, what we call the sun. But it would take years for the light to travel for, say, 6 light years. Supposedly, this is what we're told, in science, in our supposed science. Mr. Keshe says that light years are a fallacy. We see the stars in real time. What can anybody explain that, or what's with that?
Wow, real time.
Yeah.
What I've gathered so far with very many well, I'm talking about not spiritual or just my physical experience with the stars. When you put a very powerful camera on towards it, you see its structure in towards and its movement and its plasmatic movement, and its interaction. The people would say that, oh, well, there are many gases that's just moving in towards it and creating these colors and everything, and it's not. It's super far away. It's what I believe they're very near to us. Therefore, their interaction is perceived not by light years, perhaps days, perhaps minutes for some of it. That's all I can say. These are my understanding.
Anybody else with anyone else with something to say about that? Doug mentions no time communication. Yeah, sometimes called zero time communication. So, I mean, that makes sense in many ways. We can be connected. There's the old idea of a mother is connected to her child, and the child could be miles away, and the mother knows there's something, when something's wrong, something's happened to her child or whatever. She can sense it. And other examples of being tuned into events or people at faraway distances or even close by, but with no time lapse between communication. You don't have to pick up the phone and dial a number. It's instantaneous, real-time understanding going on.
Yeah, I know what you mean. I was in Florida and I knew when I had to call home. I also was in need of help, and two gals that I knew and thought of earlier in the day came in to help me.
Yeah. Yeah, and usually it's at times of stress or urgency that these these powers kick in a way.
The strangest one, though, was picking up the phone to call somebody and they're on there just talking back to you.
Yes. Yes, I've had a couple of strange ones like that occur in the
I think
past.
caustic coding environment would be sort of understanding of it. When we create this little capsule of atmosphere, to be able to create that the nano coding, we create this atmosphere. But imagine in that atmosphere, in that capsule, from one point to another, would they have the same sort of understanding, communication with each other? Would they be the same under that atmospheric condition? What I think is, when it's being caustic coding, for instance, in this example, they'll be all in the same environment, whether they're apart from each other, a million miles away, concerning your container, they'll be the same component, and they'll be experiencing the same environment, given their sort of how big they can think themselves would I don't understand. I mean, these are my understanding of it, but what do you think?
Well, if you look at if we get back to the idea of a plasmatic environment, a plasma is a plasma, and that means there isn't any material level stuff in the plasma to speak of if it's a real plasma. So, in other words, the material level stuff interferes with the plasma and vice versa. They're almost mutually irreconcilable, although the matter level can support the plasma and the plasma that can create the matter level and that kind of thing. But inside of a plasma, then it's, I think it was Alex who gave a definition of plasma and mentioned, let me see if I still have that here handy. I think I put it somewhere and tucked it away. So, but the idea was the plasma is undifferentiated material, whereas matter level stuff is differentiated material. So in the plasma, it's everything's broken up into its ionized basic particles. You have your electrons, you have your protons and neutrons, and maybe some elements mixed in. But in a high energy plasma, even the elements will be broken up, and it'll be just a floating mishmash of high energy protons and electrons, or positrons, and anti-protons and whatnot. So the idea being that that undifferentiated state has a certain existence that's common with the other undifferentiated states. They're linked together in spite of not having a form in a way. They're still, all plasmas are linked together in the same way that we might say that all water is linked together. In fact,
Wonderful.
there's a song recently that's from the Water Protectors. It's on my Facebook, one of my last Facebook posts, and it's all about water. It's a rap kind of song. It's from the native people at Standing Rock have, or somebody there has put together this really nice little video, music video. And I was really quite stunned by it in a way, because toward the end they start, talking. It's all about water, being a water protector. This is the new term. Well, it's an old term, but it's coming into common use now. The water protectors all over the world. The water protectors are rising up, and stating their case. They're protecting the water, and it's not just water in the rivers or lakes or oceans or whatever, but it's taken in the bigger sense. It's all water, okay? And when you look at it that way, okay, then it's all water everywhere. And then he starts talking in the rapping in the song, and that water is in your heart. All right, this water is in your heart, and is in the water of the heart of the people that are forcing their views, or they're building the pipelines, and the ones that are the politicians. They also have water in their hearts. So it's important to recognize that commonality of that special water that exists. It's gans water in our hearts, which makes it different than regular water, and that is the common connector, because it's special. It's got that plasmatic quality to it that makes it have a connection with all other plasmas. It's that instant communication thing. It's that that quality that's attached to that, usually attached to that emotion that we call love, and that's part of this mood, or this emotion. It's more than emotion, it seems. It's a state, pretty much.
It's understanding element of the water within you. That's just what it is, and then what you can't name it, because it's so significant. It's so magnificent,
and it's part of the pulse. It's the actual pulse of the core pulse, and because of that, it's it resonates with the pulse of other core pulses. And if you look at it that way, then one can have more compassion for the some of the more radical politicians and whatnot that might be forcing their viewpoint on others. Is that somehow they do have a heart, they do have a gans water pulsing, or we assume they do. Not everyone that may not be the case, or maybe the heart gets hardened over time and no longer pulses the gans. Maybe it's the blood turns cold-blooded. Maybe that happens. I don't know. But in any case, it seems like there's a possibility that if they're human, then they have a heart. If they have a heart, then they have a chance for having a commonality, to have a bond, a common interaction, that you can reach someone who has a heart by various ways. Could be from
the totality of understanding is being understood by the individuals are different. Therefore, their actions, their totality of representing the idea are different, depending of their desperation and what that desperation represents of the totality. And at the moment, We're being very, very professional. We think we're very, very understanding of everything, and at the moment we're rushing in towards making ideas. But being patient is the virtue is at the moment, and everyone's going to do whatever they could do to stop anything. But the understanding of the whole picture makes a big difference on individuals, and understanding of that effect of this takes a bit of a time, and it takes a bit of an experience. We're not what we think we are, and it's all going to be okay.
Right. So, yeah, the point being that we do seem to be interconnected. Okay, Mark, I see you have something fun to look at here, so I'm going to put you up instead of my face. Okay, we've got... Is this the gurgling that we hear in the background? I keep hearing gurgling going on. Is that part of this contraption? What do you got going on here, Mark? You better tell us about this.
Well, I consulted with John, and maybe John might be able to concur with me. We don't know what this is yet, but I don't know what it is yet, but this is part of my 30-day gans production run. And this would be the CUO, one of my containers of the CUO. And what you're looking at right now is it took about maybe 12 days into the production, and all of a sudden I see, because I look with my flashlight and my light and everything, and all of a sudden I got a little bit of a growth matter underneath the water starting to form around the nano-coated wire and the nano-coated pipe. What you're looking at right there is an actual, it birthed itself in this environment. Now, I don't know, for people that haven't been watching us earlier, we were told to be to experiment or just to try different things And this this is my, I do production runs, and I have a couple other containers just a little bit, next to one another, but this is on the end. And this run was made with Epsom salt and magnesium. So this growth underneath the water, at first I thought, well, mold might, everybody's first thought would be mold or a fungal, something blew into the top and it's a fungal form, but in a sulfur form, in a sulfur atmosphere, which is the Epsom salt and the magnesium, and distilled water with just a bubbler. You see the bubbling action. That there's no electricity, there's nothing else, but all natural. It's all natural, and this just started to grow. And I can probably try to get it a little bit better. I don't know how you're seeing it on camera. I don't know. Me and John talked.
It looks really clear. It looks really good. I'm just trying to figure out what it is. So, and let me get it straight here. The wire that goes across the whole jar, that's nano-coated copper as well? And the twisted wire we see that connects the pipe is nano-coated too?
Yes, everything is nano-coated. There's the wire that's across the top there that's holding it. It has degraded, and you can see the flakes of it are on top of it. For whatever reason, it broke down the nano coating real fast on the top, where the hanger of it. But it didn't really break down the nano coating on the copper wire or the copper tube. That's a 3/4 inch copper tube with 14 gauge wire wrapped around the outside of it. And that's just a little hook on the top of it that holds it, the pipe, so that you're looking at a top view of it. You're looking straight down in the top view. So
Right.
that's the hook of it, yes.
And you've created a fair amount of the blue CuO gans, right?
I mean, it looks blue, but there's no real GANs. There's this solution, and I can show you on all the other ones down the line. It's a clear solution. It's not thick. There's none of the only thick one is the CH3, and that's on the opposite end, and you can't even see through it.
But I mean, the you got some copper oxide gans on the bottom of the jar, don't you? Or
Yeah, it's blue because it drips every once in a while, and I got a container underneath it when it drips. It definitely is blue. You can see the bluish tint to it.
okay. But that other stuff at the top is pure white. There's no blue to it, is there?
No, it's pure white.
Right. Interesting. And is any of that dropped to the bottom, or is it staying on those on the hook?
Well, that's the interesting part. When I showed John maybe 3 or 4 days ago, that's the first part of it that started, that I noticed the first part because, just looking from the top down, that's what I saw. I went like, oh, wow, is that a fungus or what is that? But it grows underneath the water and it has tentacles and veins. And I don't know if can you see kind of like the veiny type structure of it.
Yeah, I think so. There's a bit of there's definitely some radial things kind of shooting around through it.
Yeah. So I don't know what. So I asked John what would live in sulfur and magnesium, and I know the ratio of it. It's I have my containers hold 3 quarts of distilled water, and I used a 10-to-1 ratio. And in a 10-to-1 ratio, there's 12 cups per. Where's my sheet? Oh. 4 cups per quart. There's 3 quarts, which would make 12 cups. So that would be like 1.2 cups of Epsom salt that I started off with. And then on the magnesium, I went 1 to 10. So there's 48 teaspoons in 1 cup. So I went 5 teaspoons of potassium. That would be a 1 to 10 ratio of that per cup. So that's what's in the solution. So that's what started. So my question to everybody is, and that's that type of solution, what would allow that to go on a nano coat, like on that nano coating? This is now started to grow, and I thought, well, this is unusual. The ones, so I watched that, but if I move the camera a little bit, there's more. It's all growing inside that pipe.
Inside the pipe too. Okay.
Yeah.
That's
Yes.
cool. So
that's cool. What do you mean?
So there's no well, it's interesting. It's a cool experiment. I wanted to play with magnesium sulfate myself, and just haven't gotten around to it yet. So it's interesting to me. Now there's no sea salt in this, right? Is that correct?
No sea salt at all. So
okay. Yep.
I hope I'm answering Denny's question or like he said, he wouldn't get to the Epsom salt experiment for a while. So I thought I asked John if I was hearing things because it was like about a lesson or two back to where Mr. Keshe said to just play with these elements. And so I thought, well, this next run that I had, I would just try this type of material. So there's no sea salt, it's just distilled water, Epsom salt, and magnesium. And this started growing. And the funny thing is, I have the exact same setup, 2 containers down, and there's nothing like this at all in it.
The exact same setup, and there's nothing like that. Oh, okay.
Absolutely not.
Well, that changes things a bit.
So it's a controlled experiment, right? Would you not say or say not?
Well, we have to figure out what the difference would be between your 2 different ones that are supposedly the same setup, though, in order to establish what the control is. So, something different here, like I'm looking at the wire here, and the twisted part that goes into the white cloud is one of the wires. Looks like it has an extra insulating layer or something on it there. I don't know if you can see my pointer if I point out to it.
Yes, I see. You know what? I think that was from when from my pliers. It looks like
It could be.
Yeah,
And does this wire does it loop around, or is it got 2 bare ends sticking out into the cloud there? Or is it just a loop that's in the cloud?
boy, I couldn't tell you because I made so many of those. You know what I'm saying? So I would venture to say that it's just a twisted loop, together,
Mm-hmm.
a continuous loop. Because that's
Okay.
how it's just one piece of wire that I needed to, like I wrapped a whole bunch of 14 gauge wire on the outside of it, stuck one end up through it to hold it so that it wouldn't fall down, and then just wrapped it all the way up to the top and just made a hook and then doubled it over, you know what I'm saying? And then just back down.
Well, gee, don't know what to say. You have to keep an eye on that other one. Surely something should start in the other one. Or maybe you could try inoculating another one with a little bit of the white stuff and see if it starts growing in the other container.
Okay, so let's go to, let me turn my monitor here. And you'll have to just we'll see if it works. Because I have to change the lighting now to see the next one.
If you could just move the container and set the other one underneath it, you won't have to change so much.
Say that again, John.
If you can simply move that container, leave your camera and lighting, and just move the containers, you won't have to change nearly so much.
The bubble just, it moved into the center of that and then it moved back again there.
Okay, so hold on 1 second.
One thing that came to my mind, Rick, when I was discussing this earlier is the conditions, the GANS conditions within that container are completely different from anything we've seen before because he's using completely different solution. So would it not be prudent to assume that what we're seeing, assuming it's not fungus or a mushroom mycelium or something like that, that this is another form of GANS surrounding the sulfur, the magnesium, and the boron?
Boron? Where's the boron from?
Epsom salts.
Magnesium sulfate. It'd be sulfur.
Oh, sorry. Okay, sorry.
Okay. Yeah, well, this is the thing. Is it a life form or is it a type of gans? I guess is the question.
That would be my question.
Because magnesium sulfate's a very supportive environment, as is salt water too for growth of things. So it's entirely possible. But I don't know. This is the what are we looking at now exactly? Is this the view from the bottom of the tube?
No, you're still looking at from the top down. See the cap
Okay.
on the bottom? So the little round ball that's on the wire that comes from the bottom up, that's the wire that holds the whole 3/4 inch pipe. Okay, so that brings the energy up from the bottom of the pipe, and now it just feeds all that. It just started growing in that whole pipe.
Nothing on the outside of the pipe other than the one spot there?
There's a little, but and I can't really, if I really try to hone in on it, it's hard to. It would be see it.
How about on the inside of the container? Is there anything happening there, or is it all confined to the pipe?
See it on the wires down there below.
Yeah, a little bit. Yeah.
See it kind of laying on top of the wires of the pipe.
Okay.
And that's the big fuzzy ball that we first started looking at.
Mm-hmm.
So then if we go in.
But nothing on the walls on the plastic wall, right?
Way down below. I don't know if a piece broke off or not, but there is definitely a piece that's laying on the bottom but I have light coming in from the bottom, but it's hard. The lighting is so hard because if I shut this one off, see how dark it gets? Is that any better?
No, it's not enough light to focus.
Yeah, it was better before, right?
Yeah.
So it's growing inside the pipe there. And there is a little bit way down on the bottom. So my question to you is, what organically would live in this environment? And there's no electricity. It's just being bubbled. So is the water, this whole environment is a plasmatic gans, because the containers, I nano coated all the containers, and I know that they've been, because this after the third run, this is my fourth run. So 1, 2, 3, I made sure I washed it, or I wash all my containers in caustic and clean them. So after the third run, I made sure that so this is brand new. Everything is purified from the last 3 runs, so I know that there's no contaminants in any of this stuff. And this is actually supporting life, some sort of life form, whether it be a fungi, or like John said, who knows? But what my biggest question is, what would life, because there's no external light, there's no sunshine.
Well, think about it. I think John had the term earlier. It was him that mentioned fungal or fungus. And if you think about mycelium or mushroom spores and the way they work, creating a mycelium network that can extend through an entire field or sometimes miles, and it's all the same cell or the same collection. It's the same plant basically, not a series of different plants. So even though it looks like different clumps, they're all related, and they're all attached with filaments that we can't even see. So it could be a type of fungus that way, and in that case, maybe it was introduced through the air bubbling system.
Oh, okay.
Entirely possible. It could be just some random spores in the air, and they got in there and they thought, whoa, we have found a vacation spot that's extraordinaire for our kind. Let's make it home. And
Right.
decided to set up shop there.
Well, I got a vacation spot in a nano 3/4 nanotube, and they're all happy and keep on coming to it because there was nothing there 2 or 3, maybe 4 days ago. And guess what? That big fat one up top is telling everybody else, everybody in the pool, this is great.
Yeah.
Have fun.
Yeah. It's quite bizarre, and the strange thing about it, it kind of looks like one of those. It looks like a nuclear reactor pool right now. When they have the light shining in the reactor pool, I was looking this up the other day, and it's from the rods in the pool actually create the light from the radiation as the particles move through the water and so on. So it kind of looks like this radiation pool with rods coming up and all this growth happening here. It's quite interesting, and so it's been like what 3 or 4 days that it's grown this much.
I talked to John. Let's see, today's Tuesday, so I told him I didn't want to say anything. It was probably Friday, maybe Saturday. Within the last 2 to 3 days, I looked in that pipe, and there was none of that there. So, but this experiment's been going on since 1/9, and the top one didn't blossom until, I want to say, I didn't notice it until probably last Wednesday. Like probably right after our class. Because I had to you got to keep putting water in to make sure that the water's topped off. And then I thought, well, wait a minute, that piece of white stuff wasn't there. And then I got the flashlight out, and I was like, whoa, what is that? So that was Thursday. So I looked at it Thursday, I got excited. So then I tried to get a hold of John, and we missed each other. So, by Saturday, we talked to each other, and by Saturday, Sunday, Monday, Tuesday, for 3 days, it took 3 days to get that much stuff in that pipe.
Yeah, wow. It'd be interesting to see what it's going to do over the next few days. It's going to fill up that pipe. Is it going to start crawling out the top? Are you going to have to get a lawnmower to start trimming it back, or what?
Well, it's going to stay with us for a while because usually I end it on 30 days. So we got another, it's like I said, I started on 1/9, and it's February 1/1. So we got about 8 more days to see what happens.
I think I felt a twinge of fear coming from that thing when you said end it in 10 days.
Get it and go, brother. You know how it is. We're here in Detroit. We're Motor City.
Yep, so it's better learn how to grow fast to take advantage of it.
It came fast and it'll go fast. That's how we do things here.
Yeah.
You know what? Whether it was hydrogen or not, I'll put a flame to it. I don't care.
Well, good stuff, Mark.
That's all I have. That's it.
I still think you should send a biopsy to the University of Michigan and say, hey, can you tell me what this stuff is?
Yeah.
then they'll kick the door down. I don't know. What would I say to them? Do you know what this is? Yeah, I could say that. Do you know what this is? How would I keep it alive? What would how would you send it off? Well,
Yeah, that's the problem. And when they test this kind of thing, usually they test it by drying it first of all, so they get rid of all the water and then they dry it, make it into a powder, and then pulverize it, crush it into as tiny wee bits as they possibly can before they subject it to the X-ray diffraction or the other types of systems to check out what it actually is. But by that time, what it was is totally different than what it is, because it's been mashed, crushed, dried, and transposed into what something that might have been alive is now quite dead. So what they actually test may be different than the thing that is.
how could you test something that would that would be alive? You know what I'm saying? Like, like, if you were to take a biopsy of it, would you stick a needle in it and just try to suck some of it out and put it on a petri dish to look and see if it was moving?
I don't know if you'd be able to see properly without a very, very high power microscope, unless it was actually moving. Maybe it's, a type of thing that you can see actual,
A pulse, like a
protozoa growth or pulse or something. Yeah, it's possible.
Well, don't amoebas and all that stuff have
Yeah, I was just going to mention protozoa or amoeba or something like that is single-celled creatures, and they can reproduce and grow and whatnot. Sure.
So they do have a way to detect that sort of thing under a microscope.
Yeah. I mean, they check for. I've got a friend that just got a job. That's her job is to look through a microscope all day long and look at fibers, asbestos fibers in this case, under a high power microscope. But other people have jobs counting bacteria under a high power microscope. And that culture dish you talked about earlier might be put under a microscope, and if they know what would be a common, you might have a petri dish and you feed it with a certain kind of solution, and you have a certain kind of growth, and then you might put that under a microscope and see, what it was and so on. People do count bacteria that way. But this seems a little different. Doesn't seem like a bacterial growth so much, but
well, I'll tell you what.
I don't know.
If there's anybody that has a greater mind, that has access to any greater than I do, here it is. It's to their. I would be more than glad to give it to anybody that would like to that sees this on YouTube or live stream or anything. All they have to do is get a hold of me and tell me the proper way to package it up and send it to them. So I'll just put it out there. If anybody has the inclination or the willingness to do this, to help us, to further us in an environment that, this is a control. I know exactly what's in there. And if they have a greater mind to know this might be something that is growing in an environment they might have thought may have never have been able to grow something. And now here it is, just because of the nano particles that are in these containers that are allowing life to be sustained. I'm not that smart. I'm a painter from Detroit. So anybody on YouTube, live stream, anybody that looks at this thing that has a greater mind than I would be more than willing to give this up.
Okay, well, these conditions are totally unique to you. Totally where you live, where actually you live in the environment where it's apartment, whether it's an apartment or a house.
Alper, that's a given. We already know that. We just would like to, I would like to be able to send a specimen to whoever has access to something greater than I do. That's all I'm putting out there.
They can't predict that. Your unique conditions is totally is you, and comparison is not applicable at all in our understanding. You can't compare with one another so that you can predict your own understanding, your own environment. I
don't
don't
even
know.
want to compare it to my understanding. I'm just asking anybody that wants to work with this sort of element, you know.
Oh
if
yeah,
they have the,
absolutely.
you know what I'm saying? I'd be willing to just do my part to send it to them.
Certainly.
Like John said, I have a university that's have great minds and great kids that spend great money to do great things.
Yes.
If they can just tell me what to do, if they have the inclination to do some experimentation to take the next step.
Well, to be honest, well, I'll come clean to you. These feelings comes from the need of it. If you need to be this way or that way, that is going to be your solution. This is how I react in my own environment, like in a different world, or that in a different earth, let's say, that I am in, and I'm expecting it, and understanding it totally the way that I am. This place is totally different, so that I create many different variations of my understanding, and I can't really say that is that. I don't know. I don't understand it. Who can prove that you're living in your environment and you're creating your own things? And how can I say yes, that's all great and that's so true? From my point of view, I don't know. It's like Denny. It's like Mr. Denny. Like, he has to do lots of experiments, and it's like we're all doing. I don't know. No predictions where came true from where I stand. I mean, it wouldn't. It was never the same thing for you. I'm not sure what I'm talking about.
I don't have a clue what you're talking about, Alper. I totally
Thank
missed
you,
the
sir.
point there. Maybe you can clarify a bit better, or I'm not sure. Anyway, let's carry on.
Okay.
Okay, so let me get clear on a couple things here with this thing, Mark. With the water level, has the water level dropped down, or do you keep adding water to it? Plain. Do you add plain water, like distilled water, or do you add any more salt to it, or sorry, any more magnesium sulfate to it, which is a salt?
The exact same measurement in a gallon. I keep it consistent. I don't. You know what I'm saying?
You mean you add more magnesium sulfate when the level drops down?
Yes.
Okay, then what you're probably getting is my magnesium sulfate crystals crystallizing. Because what you'd be doing if you do that is increasing the salt level more and more. Because the salt level, if you just add distilled water, the salt level is always going to stay the same. But if you add in water that's already got salt in it, you'll be increasing the salt level when the water evaporates, because the water doesn't take the salt with it. The water just leaves the salt behind. It actually increases the concentration when it drops down. So So how many times would you put additional water in or additional mix in, let's say? Maybe half a dozen times or something over the month? Or
Oh yeah, at least that.
mm-hmm.
Oh
I
yeah.
think that's what might be happening. You're actually starting to create crystals, sort of a
I would
crystal, a
be
fine crystal.
I would be inclined to think that if the crystals were going to form, they'd be growing on the surface and out into the air where the water evaporates and leaves them behind, not under the surface.
Well, if you grow crystals, then that's the way you do it. You supersaturate the solution, first of all, which is what he's been doing. He already started out with a 10% salt, which is pretty high ratio, and now it's probably more closer to 20% or something like that. And then with the supersaturated solution, you let it just sit there, and over a period of time, especially with a thread or some other, you see the wire there, how it's starting to coat the wire, for example. That's what crystals will do, will tend to form around a wire or thread that you put into the supersaturated solution. So this is the theory I have. We'll see. Now in that case, if that was true, then that should be happening with the other unit as well. Unless the other unit doesn't have as much salt in it, maybe it's in a cooler place, it didn't need as much added to it because it's not evaporating as much or something. Would that be possible, Mark, or is the other one the same conditions pretty much?
It's only one container away.
Yeah, you'd think it'd be the same. I'm just trying to come up with some rationale that might explain it, but maybe not too. So I'm just trying to eliminate that as a possibility.
Well, actually,
Doug mentions in the chat, and crystals are alive. Well, there you go. I mean, in a way, it's either way, it's alive.
that's CO2 because that's the nanoplated zinc plate with a raw zinc plate, and everything's just got air. So that's just nano coated and non-nano coated. That's the container next to it, and then this one is the other. Same setup.
Mm-hmm.
Yeah, I'm kind of leaning towards some sort of a plant myself.
And this would be the same, you know. That's where it's at. That's in between. That's the same setup. And then CO2 with the zinc plates again. But check this out. This is the CH3 because I have a lot of CH3, but I thought I'd make one of these. And it's as thick as, it's liquidly thick.
Yeah, the CH3 is so light because of your bubbler, it's just not never going to settle out.
Yeah, but there's nothing on the bottom of it. It's just like this CH3 here. You know what I'm saying? That's thick CH3.
Yeah, it's not being constantly agitated either.
Oh, well, this won't settle out here. This one will not settle, period. This one will. See the difference?
Mm-hmm.
This one won't. No settle.
What was the difference in the way they're made?
Same. Run 3, production 3, 2, production 2 in the back there. Oh, production number 2. I don't know if you can see the 2 on it.
Yep.
Production number 1. So I don't know.
Oh, interesting. Well, keep us posted. That's the main thing. Is we have several running experiments like this, it seems, and it's great to touch base every week to be able to tell what's going on with them. This is a great new development.
And then on the end, you know, like I said, this is the one with the 2 rocks. That's going along real nice. The 2 pieces of ore.
It continues to create gans on the bottom.
Oh yeah.
Yeah. Can't get more organic than that.
Nope. 2 rocks making hands. So that's coming from Detroit.
Thank you, Mark.
Okay. Thanks everybody.
I can say a couple of things. I've seen same conditions for the GANs production and different results from the same environment. That is pretty amazing because what we're lack of proving our intentions, how much our intentions are making the difference of our productions. That's what we lack of, and what I'm saying is exactly that. Different results of CH3 I've seen under the same atmospheric conditions. It's totally unique to him, and no one can do the same thing as he's done. It's impossible, and therefore our intentions in the equation in as equal as the physical evidence there, and then we're just because we're looking at in it the production, it makes a big difference. Looking our observation, conscious observation, makes a big difference of it, of the quality of the production. That's all I can say. That's I think we need to make a differentiality, or we need to collect the evidence of our intentions. How much of a big, what is the difference, and then we need to write it down. Maybe I should do it. Maybe, I mean, I'm talking like, these are all the things that came to my mind, and I'm just sharing it with you. All equal, on all with love. I love you.
Off. It's just saying that Doug says in the chat, we are creating living beings, not cars. It's a transition. Thank you so much, Mark. All right, so that's good. Okay, any other comments or questions on? Oh, we have another shot from Mark here. Let me get that highlighted.
Oh, that's just old Bessie. She's getting ready to get nano coated. I got all the plates nano coated now, and I just wanted to comment on one thing here. Now, maybe I could just show one thing before we go tonight. Because we were talking about the inner and the outer cores of everything that we have. And I don't know if everybody kind of got the idea of my rings that I have here. These rings here, but like Denny was saying, and I can show them a little bit easier when they're nano coated. Oh, I can't even pull them apart, but there's an actual tube inside here that this wire, this actual copper wire that you see here, goes through here and is fed through the vinyl tubing. And with this T, I just drilled a little hole on the top and the bottom, and that's what these green caps are for, so that we can put our, like where everybody was worried about putting their GANS solution, how are we going to get it inside? And I thought, well, maybe this might be just a little bit easier for everybody to get the GANS solution inside, because that 14 gauge wire goes all the way through the inside of that vinyl tube and then comes back to the outside. So that might help, as far as holding the GANS material inside the ring, and then you'll be able to put GANS material on the outside of the ring. And as you can see on my, I just did these the other, not too long ago. When you nano coat the whole plate, when you put it in your GANS, your caustic solution, the caustic, if you keep the caps off, the caustic will go inside the tubing and nano coat the tubing on the inside of the tubing, nano coat the tubing on the outside of the tubing, and actually nano coat the outside wire and nano coat the inside wire, if that makes sense to everybody. That way you don't have to really worry about inside, outside, or, worried about the nano coating or the GANS getting. You can, this way you can separate both of them and still have a gradients between the two, if that makes sense.
Yeah, it does. Very good.
So maybe, we're trying to integrate some of these vinyl tubings with the nano coating or the copper tubes too. So that was my idea, and that's what all these are. Every single one of them have all these outside all have tubes, and I'll be able to put, like the gradients of, like John said, we'll put CuO with CH3. So you put 5 milliliters of CO2 and 2 milliliters of CH3, just to give your gradients. And then you do the opposite here, where you do the 10 milliliters of CH3 and then 2 milliliters of CO2, just to give it the back and forth. And that, with these ports, you'll be able to do that a lot easier than just trying to dab it on, with a cotton swab or whatever you're going to do with a regular regular magrav unit, where you're just trying to get the if you were to just try to treat these units, how are you, how are you going to get the separation from the inner to the outer? You know what I'm saying? So I thought with the tubes, the difference between the tubes and the inner and outer, the size wise are the exact same, but the size wise, what I did was I decided to do was, if you could just see this size here is the exact same size as these here. So I just took the inners and brought them out, and I have the outers out here. If that makes sense.
Sure, why not?
Why not, right, Rick? If it
Those
makes
are,
sense to
those
me,
are
it makes sense
two wise words I learned from Mr. Keshe a long time ago. Why not? And he's launched a lot of projects with those words.
So that was just a little something extra I just wanted to throw at you. It's getting late.
Okay, very good. Thank you. Thank you for that, Mark.
Yep. See you next week. Have a
Right
great
on.
week.
Okay. Any other last minute requests, comments, complaints? No, forget the complaints. You can keep them.
Thank you, Rick. Thank you, thank you, thank you.
You're welcome, Doug. Thank you.
Thank you all. Good night.
Thank you, Denny. That was a really good expose you had of your gear there. Very interesting. Look forward to seeing what kind of structure is going to appear in your backyard one of these days. Or maybe disappear in your backyard even.
Well, I think I'll go simple first instead of going for the spaceship. Maybe I'll take some time and look at the health unit and the food unit first. And because it's all got to be part of the same thing. So I might just specialize.
Yeah, well, in a way, you have a good chance to make the Oasis unit there as well. If you can create a type of structure around the unit that you feel, comforted or safe in, let's say, and you can exist outside and feel like you've created a bubble around you. Maybe then you can watch the stars and it can be cold outside, but you still feel warm, or maybe you can, be out in the rain and still not get wet. Who knows?
Well, my greenhouse effect didn't work. It snowed on my greenhouse. Froze all my gans.
Well, maybe it's got the opposite effect, and you have to just,
I had some anomalies come with the thawing out the gans I had in containers. Every one of them, when it thawed out, the liquid plasma with the gans in the bottom, a certain amount of gans particles rose up to a certain level and just stayed there.
Oh.
And I thought, well, some kind of gas is holding that up. But then they were all on the same plane. And I took pictures, and they stayed like that for a long time. And then when I was not looking, they all dropped at the same time. And so
when you weren't looking. Yeah, that's interesting. Well, it might have to do with the density of water at certain points, because density of water increases actually at 4 degrees Celsius. That's when it's most dense. And then it gets less dense from 4 degrees down to 0 degrees before it freezes and becomes less dense again. So perhaps the density has something to do with the gans won't change its density, but the water will, and maybe
there's some kind of gas in there. I don't know what kind of gas. It could be nitrogen, it could be oxygen, it could be hydrogen.
Generally air. Generally just air is dissolved in all water. It's hard to get it out, actually. You have to vacuum it out or boil it out.
So that's what I thought it was. That's what my first thought was. And that there was air inside the little GANs particles. But I thought, well, if they were if there was air there, more air, why would there be the same amount of air in every particle? Some particles were larger than the others. And so that they would stay on the same plane. They'd raise about 3 or 4 inches up above the bottom. And it happened in a container that just had a little fine amount of gans in it. It all froze solid. And
Is that the CO2 GANs, or what GANs would that be?
it was CO2 primarily. I mean, that's the only ones that floated. The CH3 didn't. I mean, they didn't float like at the top of the container. There was some things that floated up there, but it floated on a level somewhere in the water itself.
Right.
And so I thought, well, they should have been some that were up, some that were down. Why on the same level? And so, but they were all on the same level. But it still had to be some kind of gas. I thought it wasn't a plasma field in a way that was saying a magnetic force or a gravitational magnetic force that was holding them up, because something at the bottom of the GANs was more magnetical, and these things were like little satellites floating in the medium of the water. So that was an interesting thing that happened with the anomaly of the freezing. And like I said, when I stayed there for 3 weeks, and then when I wasn't looking, I looked, and it was all gone. And they all dropped to the bottom, and it did that in about 4 different containers that I had, 5 containers that I had. One was a 2.5 gallon container. One was just a quart jar. Another one was a gallon, and they all seem to have that little technique. But now the gallon jar that has a lot of GANs in it, I can shake it, and I can get the gas bubbles to come up, and it brings up a lot of GANs, and it comes up like a little whirly jig. So it's fun. I could probably go get the thing and bring it in, but I can do it next Tuesday just as well, just to see the little gas bubbles come up and how it brings the GANs up. That was an anomaly that was fun to watch. And so it's like the first thing that you want to, what kind of conclusion, what kind of a thing you're going to jump to, what kind of a conclusion is it a magnetical thing? Why on the same level? Why are all the, so you ask these questions, and I just still thought there was some kind of air bubble that was holding him up, but there seemed to be a relationship between every air bubble and the GANs that would hold it on the same plane.
Yeah, that's odd, all right.
That was the anomaly. And then when they decided to quit, they all quit at once.
When you weren't looking, even.
Yeah, I could have.
This is sign of a conscious GANs. He's just trying to play games with you.
Yeah,
hide and seek is always the first games that kids like to play.
I still got some stuff out there that are frozen solid, so I can still experiment with that. And I can put a time lapse on it if I so choose, because I'll trick them. That'll trick them. They won't be able to pull that trick on me again.
Yeah, we have the technology nowadays to catch them in the middle of their act.
Besides, it's still below freezing out there. I can set them back out and give them another try.
Yes, that's true. Well, that would be interesting. It'd be great to see a time lapse of all that going down. That'd be pretty neat.
I think I can make a spaceship before I can put together the time lapsing stuff.
It's easier just to make the spaceship.
Okay, well, I'll see you later.
Okay,
Goodbye,
thanks, Denny. All right, I think we're going to wrap things up here. Any last minute things to say? All right, I think we pretty much there. Jansk says, highlight of my week always in the live stream. Many thanks to everyone. Appreciate your touch of humor, Rick. All right, that's good. All right, on that note, let's leave it for now, and thank you everybody for attending and participating and having fun here at the Keshe Plasma Reactor Group. for what's now is Wednesday, February 1st, 2017. Ready for another fresh month here in this year. And looks like it's going to be an exciting one, the way things are going. So looking forward to it. All right, we'll end the live stream.
Thank you, Rick.
All right.